About MRI scan, what I earlier told, one is basically about the different brain structural brain analysis. But whenever it is a computer aided models, it is a computational models. But again, I repeat this statement what I earlier told, it is not only restricted to brain abnormality only, it can be go for that particular computer aided diagnosis framework may be applicable to different disease specific also. It may be also applicable to a particular computational model, may be applicable to your digital mammogram classification, what we are talking of breast cancer. We will also use it as a liver abnormality, kidney, your different types of also post-trade. Nowadays, there are so many also other diseases analysis maybe people are doing, because lots of work has already been done on breast cancer and brain, but now they are targeting to other kind of diseases also. For an eye also, nowadays it is a very hot area of research, like your digital retinopathy, like a diabetic patient or a non-diabetic patient, due to what particular reason that particular nerve or the particular has already been open. Okay, then then this is the computer aided diagnosis system. So especially there may be some background noise from the audience. Maybe some background noise, please mute. Hello, excuse me, there may be some background noise. The participant Nitya, I request you to mute.
Yes, sir. Yes, sir. Yes, sir.
Okay, ma'am.
Okay, thank you. So, what is the role of computer-aided diagnosis systems? So first you have to understand it, because you have a radiologist, you have a medical practitioner. Suppose you will undergo for a particular test. So this particular test suggested that yes, there is a malignant or there is a cancerous cell is already been developed inside your body. So though we are talking of the brain abnormality, there may be some kind of your brain abnormality is going on inside the human brain. But the thing is that what is the advantage of computer-aided diagnosis system? Sometimes the conclusion or the interpretation of the radiologist may also fails in some cases. I'm not talking about 100% fail. So basically, this is a second opinion for a medical practitioner or radiologist to give a proper interpretation about that particular disease. Then he or she, the medical practitioner or the doctor will suggest the patient whether he will go for a biopsy or whether he will again go for, after that the further treatment is mainly concerned. So basically it is a tool tools, mathematical computational tools, to properly analyze the particular specific disease. And to do this, we require some kind of image processing and computer vision tools to develop that particular frameworks. So what are the process involved in a CAD? So initially, you have to have a image acquisition. So here we have been written medical image acquisition. So first you have to find out, you want to first extract the imaging, the proper imaging from a specific equipment. Okay, because ultimately you have to work on an image, whether the image is, whether it may be MRI image, whether it may be a CT scan image, whether it may be a functional MRI, whatever it may be. So ultimately we have to work on an image. So that is my input. After I am obtaining that particular input, then we will perform some kind of pre-processing. It may so happen in that particular image, you might have found some kind of noise, you might have found some kind of artifacts in some agency or some medical or in some health center, you have some X-ray kind of image you have, so they have some kind of labeling. So you have also observed some kind of labeling. So to remove the label, to remove some unwanted muscles, to remove some noise, to remove some artifacts, you want to do a proper pre-processing. Because without the pre-processing, what kind of image you are going to deal, so the analysis will not be so proper. So in case of image processing, to do the pre-processing, one of the very famous example of image processing is called image enhancement. Okay, image enhancement is a technique to improve the pictorial quality of a given image by removing the noise, by removing the artifacts, by removing the label, all these things. Then after this, the most important thing is that throughout the entire image, you will not require the entire image. You will only interested for what? In which particular area that particular growth has already been occurred. So you want to extract only that particular suspicious region, right? So the entire image, a particular brain imaging, the entire image of a particular patient is not affected. In a particular specific area, it has been affected. So segmentation is basically does what? It gives you, it extracts the region of interest. In some research, manual segmentation is done. That means you can go for a cropping, or you have a ground truth. Already the radiologist has given, this is my ground truth. Ground truth means in that particular area, the ROI, he has given you the ROI. You don't have to think, or you don't have to worry about the ROI. This is not our work. After ROI extraction, we have to work. Okay. So ROI is already available. But the challenges is more. The research is more evolving on this particular challenge of segmentation, how we will make it automated. So if ground truth is not available, if this particular ROI is not available, then how automatically we can segment this particular image, how to obtain the ROI automatically. Then after that, with that, because we will not work on the entire image, rather than we will work on the ROI, that extracted image. So from the extracted image, the next thing is that we want to extract the important features, because this is the most important module in every kind of digital medical imaging analysis. Which features are more prominent, which features are more optimal, which features are more important to us. There may be many features, but you have to ultimately work on what are the prominent or dominant features. So feature extraction is one of the important criteria. Okay. Then followed by what I told, suppose by a feature extraction, you have been extracted 70 to 80 features, but later you observe out of 70 to 80 features, all features are not contributed equally. Some are contributed more, some are contributed very, very less. So this leads to the concept of feature selections. Feature selection means out of 70 to 80 features, after feature selection, what is the output? Suppose if I am obtaining 20 features are actually contributed. So we are obtaining basically a reduced set of feature vector. Initially, our feature vector is composed of 70 features. For example, F1, F2 up to F70. After feature selection, it will be a reduced feature vector, that will be FR. That means F1, F2 up to F30. Okay, so this is the idea, and also that helps the researcher. If you do a proper feature selection methodology, your accuracy will be prominently improved. Okay, sometimes there may be some outlier, there may be some compound feature, there may be some redundant feature. So for that, your accuracy, what you are obtaining, you are not obtaining a very good accurate features. So feature selection is also played a very vital role. Then next one is, after feature selection is over, then with that reduced set of feature, also to the classifier also, feature selection also helps. Why? Because instead of you are training with 70 feature, it is better to train with a less number of feature, because as you go on increasing the number of features, it may so happen the classifier complexity will be very, very high. So if out of 70, if within 20 feature I am able to do my analysis properly, then what is the justification of using 70 features? Okay, so it also directly also helps to the classifier module also. So after that, there is a training module, or we can say it as a classifier, to classify the features as per these supplied features, and giving us a level, or giving us a categories or classes, whether it is normal or abnormal. Again, if it is abnormal, whether it is benign or malignant. If it is benign, obviously there is a tumor, but it is not cancerous. But if it is malignant, there is a tumor, also it is cancerous. Okay, then deployment of this train model. Once the model is trained, once the model is generalized, then whatever may be the other images, the rest of the images, you are not using, you are not considering during the training. You have to test. Test is also very, very important. Sometimes training accuracy is very high, but testing accuracy is not so impressive. It is not so close to training. Suppose training accuracy is 95%, maybe testing accuracy is 75. So there is a gap of 20%. So it may so happen also, you can have think of what kind of problem due to any overfitting kind of issue, or due to some other kind of outlier is basically present in the data set. My data set preparation is not proper. I am not giving any kind of scaling, proper normalization. My data set is not prepared well. Due to that reason, my training and testing accuracy will vary so much. Okay, so also there are some kind of technique to also improve the generalization of the training efficiency with respect to testing. One such example is called your regularization. Regularization technique is basically helps. If your testing accuracy is low, very low as compared to training, it will improve over the time. It will match to the training accuracy to a greater extent. Okay, so this is all about your the necessary steps involved in a computer-aided diagnosis systems. So what I told, this is the case. This is the figuratical diagram for this. You have a data set. There are so many data set of brain imaging modality. Then you have a separate training or testing set. It may be 70-30, it may be 60-40, it may be 80-20. As per your convenience, you can draw. Then already I taught you have a pre-processing. You are removing noise, artifacts, all these things, followed by segmentation, whether it is a manual segmentation or automated segmentation, followed by you are extracting the dominant features. Then feature selection is not compulsory. Okay, you may go for that. It is better to go for a feature selection methodology. Then followed by you train a classifier model. Then you obtain a train models. After train models, then there is basically helps as a second opinion to the radiologist or the medical practitioner. During the testing, again the same thing, but you are not doing the other step. Already the model is trained. So those rest of the images you are not been considered during the training. You directly fed it up to the trained model or the generalized model. Then it will accordingly categorize or classify the particular case. Okay, so this is the workflow of a computer-aided diagnosis systems. Here we are mainly targeted for brain tumor analysis. Okay. Then this is the segmentation. Already I told. Segmentation mainly manually or automated, but in general we can say it as this is a traditional unsupervised clustering of segmentation method are basically the different researchers are undertaken. So they are basically some kind of clustering technique like k-means, fuzzy c-means, self-organizing match, which is commonly known as SOM, etc., etc. Okay, if you go for any kind of this is basically automated. For manually, it's just like a crop. For a automated, for a traditional unsupervised, because unsupervised means you don't know about the level, you don't have the ROI with you don't have the ground truth with you. So there are so many clustering algorithm people are adopting. Okay, nowadays for last 5 to 6 years, people are more interested on deep learning methods. So using deep learning convolutional deconvolutional network or autoencoders or UNets, there are so many deep networks now available. You can also do this segmentation by using not only using the traditional approaches but using a deep approaches. Okay, so this is one example of a traditional segmentation. You have an original image, you have an enhanced image, then followed by this is the threshold, means we are going for a binarization of the image. Then this is morphological operation, any post processing, then followed by this region, only that region, then finally we have a overlay on that particular region, ROI extraction, because ultimately we have to work on ROI. This is the segmentation of a deep network. Nowadays you heard about the CNN and all these things due to time shortage, because after that another talk is also is going to be scheduled. So you can also go for this. You have a training set, you have a testing set. Then the same methodology has been used in both the cases, but you have a CNN here. Here we have been presented a very powerful deep network that is called convolutional neural networks. And finally you have a segmented image like that. And this color part is basically your ROI. This is your region of interest. Then now coming to the most important thing, that is the feature analysis. There are so many features which exist. Like what I have been mentioned, first order features, shape-based, gray level, cross-diagonal texture metric. There are so many transform-based like Gabor transform, wavelet transform. Local feature, if someone is interested to capture the image information locally, more accurately, then also we'll go for local feature analysis like local binary pattern, histogram, shifts, sharp or deep features. Nowadays, actually there are two categories. One is called handcrafted features. Those who have been worked for the machine learning community, they have handcrafted features. We have to extract the features by our own by adopting any technique. Whenever we are coming to deep features, deep learning has the capability to learn the features through its help of deep networks, because in every layer you will get the discriminative features, the important feature. But there is a very big debate in deep learning. Should we have a proper feature analysis why these features are basically selected from a deep networks? There is a debate is still going on, but due to capability of deep network, it has been observed that what basically features we have been obtained from a deep neural network, that is the best discriminating features to be used for the further modules. Okay. These are some manual features. These are shape oriented, like area, perimeter, circularity, irregularity, shape index. If you are coming up fast order, like histogram, mean, variance, skewness, kurtosis, pixel orientation, texture feature also. Also there is a differentiation, whether you deal with shape type of feature, fast order, texture feature, or deep features, or transform feature, wavelet, high or low. So nowadays people are doing basically what? They will having a fusion of features. They are not only restricted to shape or fast order or texture. They will take some important feature from texture, some important feature from transform based, some fast order important features. So out of this 30 feature, for example, of this 4 category, they will choose 6 to 7 feature of different combinations. Okay, so this is the case, and this is a deep features. I have presented a snapshot of this using initially you have a 7 by 7, then you have a finally you obtained a feature map of 5 by 5, and you have a filter of 3 by 3. That filter will move throughout the entire image 7 by 7 window, and from time to time, over the time, we are getting this particular output. There will be 3 channels because we are dealing with a color images, RGB. Okay, So there will be 3 channels. So basically it is called kernel, or we are also telling it as a filter. Okay, we are obtaining a 3x3 filter here. Then coming to classification of brain imaging, people are working on different aspect, whether it is a 2 class, very simple, either normal or abnormal, or benign versus malignant. Some are using also 3 class problem, normal versus benign versus malignant, because the abnormality, they have been, from the first step, they have been categorized as benign and malignant. So there is a 3 class or multi-class, normal versus number of tumors. Okay, number of tumors type. So whether you will go for a 2 class classification, or it may be so happen you may, instead of going to a next level, you are categorized into 3 level, or in most of the cases now it is a challenging tax, you will go for a multi-class classifications, N class. And classification models, some traditional classification model in machine learning already we have been heard about, like MLP, logistic regression, your RBF, your FLAN, okay, then naive Bayes, K nearest neighbor, decision tree, CJ 4.5. These are some traditional. Coming to deep networks nowadays, convolutional network, connected neural network, recurrent neural network. So I have been categorized, but mind it, whenever we are dealing with imaging modality, mainly CNN is always better than RNN, recurrent neural network. Whenever we are working on sequencing kind of data like bioinformatics or some other kind of sequencing modality, RNN is good. But whenever we are dealing with some non-linearity pattern in an image, it is better to use the convolutional neural networks. Okay. This is the example of a 2 class classification, normal versus abnormal. Left is normal, right is abnormal. This is a benign versus malignant. One is a tumor, but it is not cancerous. Malignant is a tumor, also cancerous. 3 class also like that. Also, that labeling is my suspicious region, my ROI, mark my cursor here. Okay. Then these are some traditional classification, classifier, like decision tree, K nearest neighbor. You have some samples, then that particular sample should be properly separated or classified. And there are different strategy to solve it. Whether it is a K nearest, you are adopting a voting concept. If it is a decision tree, you have to build up a forest like this. If it is logistic regression, there is a clear separator. Okay, there may be some false, there may be some true samples. If it is a support vector, this is called a hyperplane. That hyperplane should be maximized. There will be a proper labeling between the positive as well as the negative data. That particular margin should be maximized. Okay. And these are some very deep neural network nowadays people are basically using. These are some example of neural and deep networks what we are talking about. Okay, these are some selected references. Okay, so thank you very much, because as the time is too low, so my presentation I have been prepared like that. I have already given you a very brief and generic idea about the neuroimaging with respect to brain abnormality. It may so happen some future direction maybe you will work on different feature analysis, number 1. Number 2, most of the researcher, they are working on a manual segmentation approach. So why not will go for an automated segmentation approach. Then third one is there still exists some work in machine learning. So it is a good area to combine both machine learning and deep learning approaches, okay, to make a hybrid kind of model to deal with both handcrafted features and deep features. And classification is based on the deep neural network to make the accuracy rate available with you. Otherwise, supervised is not possible.
Yes, sir. But
So
sir,
you can
what's the
mix up.
problem?
Yes,
Okay.
you can mix up. You can mix up your work. Those data set you start with, those who are available with some data sets with some level, you work on some supervised model for that.
Yes,
After
sir. Yes, sir.
after that, if you find you don't have some kind of data sets, they are not giving the proper ROI or the proper ground truth, so you go for the unsupervised methodology for that
Yes,
particular
sir.
case.
Actually, as many researchers, they are working
But
nowadays, sir, on supervised method, basically on the
yes,
deep
yes,
learning.
but as per your question is also concerned,
Yes, sir.
pre-processing is must.
Yes, sir. That is required.
Whether
Yes,
it
sir.
is unsupervised or supervised, it is after that. Pre-processing means you have to do so many things, not only noise removal or your artifacts removal or any kind of labeling, any kind of muscles, any kind of unwanted lesion in case of skin, but you have to do so many kind of enhancement technique to first get a very proper ROI. Then you can go for whether you go for a supervised or you will go for a unsupervised.
Okay, sir. So one more question, sir, regarding to the training and testing data. Sir, as you told that during your presentation, you told that as per our choice, we can take training and testing data like 60-40 or 70-30 or 80-20 or anything as per our
It
choice
is
we
it
can.
is it is better always you will have a cross validation. There is a cross validation, k-fold.
Oh, sir. Okay,
Okay,
sir. Yes,
always
sir.
k means you run the samples in different fold, k equal to 5, k equal to 10, then always averaging is better. That is called k-fold technique. That is called cross validation. Then
Yes.
whatever may be your clustering of the data is basically means how on what way you can make it mix 80-20, 70-30 or 60-40. So always there should be a cross validation.
But
So
what is most acceptable by the reviewers, sir? Generally, because some papers I found 70-30, some are.
yeah, in most of the cases it is recommended 70-30.
Oh, yes, sir. 70-30.
Because
Okay,
in
sir. My. Yes.
training, as much as different type of instances you have been trained during the testing, 30% is sufficient. So that's why in
Okay.
most of the cases 70% of the training data
Test training and
is been
30% is testing. Yes, sir. Sir, this is my last question, sir. Sir, regarding when I did one work related to the segmentation by using the deep learning pre-trained network, sir, I got the variation in my validation accuracy, my global accuracy, and my local accuracy. The data what I found, or the result what I found, sir, the difference is very large. Why, sir? It is like that. Validation
no
accuracy, I am
again.
getting nine.
Can you repeat again?
Yes,
Again
sir.
there
Yes,
is
sir.
a
Yes, sir. Is it audible, sir?
no, yeah.
Yeah, okay, sir. Sir, actually, I did one segmentation in the deep learning method network using the pre-trained network.
Okay.
Sir, what the result I found, my validation accuracy, my global accuracy, my local accuracy, and my mean accuracy all are differing, sir. The validation accuracy, if I am getting 98 point something, at the same time I am getting my global accuracy 94 point something. Why the difference is so large, and how I can achieve that the difference? In
Yes,
between it will be
so
less.
already I talked one point regarding my presentation.
Yes, sir. Yes,
In
sir.
most of the cases, it is a problem for every researcher. One of my scholar is also working recently for last 2 years. So training, it may so happen during training and testing, there is a very large gap.
Yes, sir.
If training accuracy is 95% and testing is 91, it is advisable to accept this. But if training is 95, testing is 75, there may be different reasons for that. So you have to manually analyze all these things properly. It may be due to some kind of your overfitting of the data. So that's why I am categorically told during the data set preparation, during the pre-processing work, you have to carefully do all these things. There may be so many outliers are there. There may be some kind of redundancy are there. There may be some kind of decorrelation of the data may be present. So you can represent your data set in such a way that you should remove all these anomalies in a very proper way. So another thing is that this is one thing. Another thing is that already I pointed out there is a term called regularization. So
Yes, sir. Yes,
regularization
sir.
approach is basically improve the testing accuracy with respect to training. So it may so happen in every network like SVM you talked of, or any kind of deep network you talked of, or you are talking of extreme learning machines, ELM nowadays people are also using. So there is a some important parameters are there. There is a regularization parameter in SBM, capital C, and also there is a kernel parameter, maybe sigma. So
Yes,
in
yes,
most
sigma.
of the cases, people are using the value of C and sigma heuristically, manually. So due to that manual selection, because the nature of the data, the nature of the feature analysis are not consistent. So it may also advisable you will go for some kind of parameter optimization for that particular model. It will be more giving added advantage to your work. You will do a classification along with a parameter optimization strategy. Whatever may be the parameter present in a given network, you want to optimize those parameters, and these parameters are adaptable over the time. It is not a fixed value for C like 2.3. It may be 2.3, it may be any adaptive value. Over the time, it will be changing. Okay. So that is the case. You have to got a very optimized value for that.
Okay, sir. Sir, thank you, sir. Thank you so much, sir. Actually, you started your presentation from the basics up to the last year. Really, it was very good. Thank you, sir. Thank you so much, sir.
Thank you so much.
Sir, good afternoon, sir. Sir, good afternoon. I have a doubt, sir. I am Mr. Radhanath Patrick.
Yeah, Radhanath, told. Tell.
Sir, actually, suppose if you are going to join, sir, two deep networks, sir, suppose DensNet and RSNet, or three deep net if you are going to join, sir. So
Radhanath,
what is the best possible?
Your voice is not
Sir,
properly audible now. Can you again repeat?
Sir, sir, I am saying, sir, regarding deep network, sir, suppose if you are going to join two nets, sir, KeresNet or DensNet, how it will be done, sir, actually?
Okay, can you write your question in the chat box? I am not properly audible.
Sir. Sir, written, sir.
Okay, as per my observation is concerned, no, you
Sir.
should not get any benefit for that. As per my experience is concerned, we are working a lot on that. Joining up two deep network, because first we have to give the justification. Why joining? Maybe you go for any kind of networks in isolation. First you have to study. First you have to study in isolation, like Keras, then DensNet. Then if you have a proper justification, then you will go for a joining of these two. Better to not join, it is a fusion. But that fusion strategy, that fusion strategy you have to be developed. Why this is so? But for the time being, it is not a proper answer. I am not giving a proper answer to this. I cannot tell. Suppose you first study both the network in isolation, what results you are obtaining, then after combining or after fusing this particular case, also for a fusion there may be some strategy you have to write. You have to write the policies. What are the strategy? Then if you are obtaining some good result as compared to individual networks, then you have a proper justification on that. But arbitrarily we cannot say by joining these two, we are claiming that we are obtaining a higher result as compared to studying the network in isolation. Okay.
Thank you, sir. Thank you for your valuable insight.
Sir, sorry, sir, the interruption, sir. Sir, can I ask one more question, sir? Sir, I am Ranjita Raut, sir. Sir, Subhendu, sir?
Yes.
Sir, actually, one more question, sir, I want to ask. Sir, when I have gone through the file exchange, in the MATLAB, some examples I found for the YOLO, sir, I am telling the pre-trained network, so YOLO V2, YOLO V4, and RCNN, region-based CNN. Some examples are there in the file exchange, sir. So what I found there, everywhere they are going for the classification, they have used the dataset, Vision dataset to classify a person and a car. And in the file exchange, what are the coding? It is available. So first they are doing they are just calling the .mat file for that particular data set. The data set, it is saved as the .mat file. So how I can save my data set in my in the .mat file, sir? That is the problem also I'm facing from last 1 month, sir. So that's
Okay.
why I can't proceed.
Okay,
sir.
I recommend it because two of my scholars are working in my IVP lab.
Okay,
So,
okay, sir.
so you can take my number from Radhanath. Radhanath, I kept my number, so I can help you on that. But
Okay, okay, sir. Okay, sir.
they will help you regarding that particular case.
Okay, sir. Okay, sir. Thank you, sir.
Insights on machine learning and guidance on computer-aided diagnosis framework for brain tumor analysis. You have shown us how to enter this area and research in upcoming technologies. Sir, I request you to switch on your camera so that we can take a snapshot of this moment. Sir? Hello, Suvendu, sir.
Yeah, I have already switched on my camera.
Yes, sir. Yes, sir. Taken, sir. Thank you, sir.
Thank you very much. Okay, Radhanath, one of my student has already worked recently, that particular case, extreme learning machine with the combination of deep neural network. You can contact him. He will guide you as per your problem is basically concerned. In which area you are working, Radhanath? Okay, sure. So recently, as per your question is concerned, the uses of extreme learning classification layer in deep neural networks. So exactly he is doing the same thing, okay? In a brain MRI.
Thank you, sir.
Thank you very much. So can I leave now?
Yes, sir.
Okay, thank you very much for giving me the opportunity. Okay.
Thank you, sir. Moving forward, attendees, we feel honored to have with us the honorable guest, Dr. Mrityunjay Panda, sir. Good afternoon, sir.
Good afternoon, student.
Yes, sir. Dr. Mrityunjay Panda holds a degree in computer science from Barampur University. He obtained his master in communication systems from College of Engineering, Budla, under Sambalpur University, MBA in HRM from IGNU, New Delhi, Bachelor in Electronics and Telecommunication Engineering from Utkal University in 2002, 2009 and 1997 respectively. He is having 19 years of teaching and research experience. He is presently working as an associate professor and head in the PG department of Computer Science and Application, Utkal University, Vani Vihar, Bhubaneswar. He is a member of KES, IAENG, ACEEE, IETE, CSI, ISTE. He has published about 100 papers in international and national journals and conferences. He has published 10 book chapters, edited 5 books in Springer, Taylor Francis, IGI Global, River Publishers, etc., to name a few. He has authored 2 textbooks on soft computing techniques and Universal Science Press, New Delhi, and Modern Approaches of Data Mining, Theory and Practices by Narosa Publications, New Delhi. He has published 1 special issue in International Journal of Computer Intelligence Studies, InterScience, UK. He serves as an associate editor, editorial board member, and program committee member of various international journals and conferences. He is an active reviewer of various international journals, including IEEE Access, Applied Soft Computing, and Neural Computing. His active area of research includes application of data mining, granular computing, big data analysis, Internet of Things, intrusion detection and prevention, social networking, wireless sensor networks, image processing, natural language processing, etc. So, without any further delay, I would like to request Dr. Mrityunjay Panda sir to enlighten our audience with your precious words on the smart and sustainable technologies. Sir, please.
Thank you. Thank you very much for your nice introduction. Warm greetings to one and all present over here in this virtual conference, ICSST 21, being organized by Electronics and Telecommunication Engineering or School of Electronics Engineering, GIET University. So I thank the organizers for inviting me to give a talk in this special occasion. So I will try to share some of my views on a recent topic. So I'm just sharing my screen. Now is it visible? Is it visible to all of you?
Yes, sir. Yes, sir. It is visible, sir.
Okay. So today I will be speaking about a very prominent.
Sir, Mrutyunjay Panda, sir.
Yeah.
Yes, sir. Good afternoon, sir. Sir, kindly go for the full screen, sir.
So I've gone for the full screen.
No, sir. It is not showing. Yes, sir. Now it is in the full screen.
Okay.
Okay, sir. Thank you, sir.
So as the conference theme goes for sustainability, so I tried to choose a subject, a research subject basically, that gives lots of emphasis on today's scenario for the hearing impaired persons. Okay, so the government of India is coming in a big way to help the hearing impaired persons. So we understand that being a technocrats, any kind of research that we are going to do shall have some societal effects. So to that effect, understanding those into our mind, so many researches are going on the sign language recognition systems. And today I am trying to just share some of the basic fundamentals and the research that is going on and the pitfalls that are occurred or that have been seen in Indian sign language recognition systems using machine learning and deep learning. So the prime agenda of this is that we will understand the basic introduction to sign language and the recognition systems. Then what is the need of a sign language recognition system with its architecture? Then we'll understand the various literature that are available in Indian sign language recognition system, followed by some techniques, the machine learning techniques that are being used. Then we'll understand what are the simulation environment that are currently people are doing in terms of hardware and software. Then challenges that we are facing in developing a sustainable ISLR systems, followed by conclusion and some references. So you can see, as I have said, when people are going to communicate with hard of hearing people, or you can say that hearing impaired people, they could not able to communicate properly. Hence, those people, those who are hearing impaired, feel something different. They are getting frustrated to see that they could not able to communicate with the normal people and they cannot do the things what they could be able to do it. And the hearing impaired persons number day by day is increasing in India and in worldwide also. So to that effect, all over the world, all the governments are taking steps to see that how to take some measures to see that these hearing impaired persons can be benefited for some kind of technological advancement. And artificial intelligence, Internet of Things, some sensor networks are coming together to see that these are now taking a step, even though it is not matured in today's research scenario, still it is taking a step by various government regulations that are coming up. So when we think about the sign language, so we are thinking in terms of gesture. So when a body gestures or any type of motions that the body is conveying to the persons, those who are in front of you. So we can categorize a gesture is a motion of the body that conveys some information. So a hearing impaired person try to create a gesture, and through the gesture, if the people can understand, then it is a good way of communication. And the people having enormous capability, but they are hearing impaired, can do miracle for the society. So we can understand that whatever form, gesture form, we'll understand what are the various forms of gestures available in subsequent slides. But you can understand that any form of gesture or a gestural form, it has some predefined pattern and meaning. So you can see that if a deaf people you will see, they can raise any hand and they will be speaking something which we may not understand, but they have their pattern and they have the meaning behind that particular gesture. Okay, and that is the main aim of that particular gesture shown by a deaf person is basically intended to transmit some messages for the conversation. And this type of conversation is known as sign language. So how these conversations, how the language is being transmitted by a deaf person so that the normal person can understand. And how the normal person, when try to speak something, and if somebody is not able to understand it, then how to do that. So speech processing comes into picture, image processing comes into picture, natural language processing comes into picture, machine learning comes into picture. So many technologies are combined together to see that this particular research is fruitful. Now you'll see that what a sign language is, how a deaf person or hearing impaired person can generate the sign. You can see that it can be by a single hand or a double hand, or using some fingers, arms, or a combination of them. Whole body may also be involved in generating a sign also. So these are the things that any body movement, not only the hand, even though there are many researches are on hand movement, even the facial expressions. I will show you some slides that some facial expression also if the people does along with the some hand movement, that also gives you a gesture or a way of communication by the hard of hearing people or regular communication with the normal people. You can understand that a waving the hands is a gesture that suggests goodbye. Now suppose a hearing impaired person just showing a sign of waving the hands, then you can say that that is a gesture, and the meaning of that gesture is goodbye. As I have said in the very first line, so every gesture has some pattern. The pattern is waving the hands. Waving the hands are nothing but the pattern, and the meaning behind the waving of hands is that he try to communicate to you goodbye. But if you see that movement of body parts, if that do not convey any specific meaning, is not considered a gesture. Okay, so the example of such is pressing a key when you are sitting in front of a computer, keyboard. So it is not considered to be a gesture. So a gesture with some gesture is that the signs which have some pattern and meaning to that. So we can say that already I have said that the gestures, when we are considering from any body movement, we can get it, including face and hand. And the sign language broadly can be divided into two types, that is static or a dynamic sign language. So starting like this is an example of a static sign language or static gesture. It represents a constant or fixed gesture without any movement in hand or any body part. So somebody is showing you one. So you see in the picture that one is only raising one finger, two fingers, and raising three fingers cannot make you that the numbers are being represented. So when this is the consideration, then you can say that this is nothing but the static gesture or static sign language. Now, if you see that it is a dynamic sign language or dynamic gesture, you can say that there is a dynamic movement of hand or any other body parts. So somebody is standing in a gesture, and that body and face, you can say that it try to speak something about good morning. Okay, so just see how it says that what is good morning. A person stands and try to speak something. Now, when we have understood what sign language means to us, how the information being communicated by the deaf people to a regular person for the effective communication, we have to understand more detail about that. So we need to pre-process something. Even any kind of data analysis, image analysis you want, you need to have some pre-processing techniques that we will discuss. But here to combine what we have discussed since last 2-3 slides, you can say that the sign language is heavily relied on the hearing society, because we are trying to develop some kind of artificial intelligence tools and techniques that can help the hearing society. Okay, so that they cannot feel they are something away from the world. Okay, so they are also part and parcel of the world where their contribution is highly important for the society, even though they are hearing impaired. And in that, we have already discussed, but here something different definition of various elements that are available in sign language. And the elements, two elements that are being developed here is either a simple level or it is called as low level sign language. And when we are considering a low and simple level sign language, it consists of alphabets. Okay, so A, B, C, D are the alphabets. So we'll show how the alphabets are represented for Chinese language, for Indian language, for American language, for French, and all these things, and how Indian sign language has come up, we'll see in the subsequent slides. But you can understand that when we think in terms of sign language, the sign language can have two elements. One is low or simple level sign language, which consists of alphabets, where the alphabets are nothing but mimicking the letters of the any native spoken language. If it is a French language, the alphabet corresponds to their own native language. If it is an Indian language, we can represent it in terms of A, B, C, D up to Z in our native spoken language. And the other element is your higher level sign language. So if it is a higher level sign language where we can use some action. Just now I was showing the dynamic sign language. Somebody was standing and tried to say goodbye or good morning, something like that. So in that, some actions are being shown. So their face is also there involved, hand is also involved, and body movement is also involved. Okay, so all these actions, so they are not static, they are considered to be dynamic. So these dynamic actions that mimic the meaning or description of the sign. So next we are considering how an Indian sign language has come into existence. So there are literature search. They pointed out that the sign language are radiated throughout the globe. It is not that any language is very specific. It is a radiated language throughout the globe. where the Indian Sign Language is acknowledged as ISL. Indian Sign Language is represented as ISL. And you just see there are some movement of fingers are shown. Okay, so we'll see how these movement of fingers are being understood by the artificial intelligence tools in subsequent slides. Okay, so according to 2011 census data, the India has around 50 lakh people who are hearing impaired. And the data may be very large if we go for the actual data and can get it from the census. So that for that reason, the Rights of Persons with Disabilities Act has come into existence by Government of India, RPWD, that is an act being done by Government of India in 2016 to see that the human right of hearing impaired people are preserved. Otherwise, when the hearing impaired people try to speak something, try to communicate with the normal people, and if they feel betrayed, then as per the constitution, they think that our human rights are being violated. So that is why, in order to safeguard the human rights interest of the hearing impaired people, as the numbers are very large today because of any kind of pollution, you can think of sound pollution, etc., etc. Hearing impaired people numbers are increasing day by day. Hence, you have to think about how these hearing impaired people can be given some kind of mechanism to see that their communication power to the normal people could be achieved in a greater extent. So see, these are some of the Indian sign languages. Pictures are shown in the right side, how the hearing impaired people show by the hand movement. Okay, so hand motion movement, you can say that one. So A, B, C, D up to Z, you just see how these things are being represented. But if that will be shown by a hearing impaired people to a common people, the common people will not be able to understand that which one is A and which one is Z. So you need to have some mechanism so that the other side of the people can understand it. And when some normal people can also speak something, then also equally understood by a hearing impaired people. So the history behind developing Indian Sign Language started in late 70s. And the research going on, research still going on. It is not yet mature. People are still trying to develop many machine learning algorithms, many deep learning algorithm has also been applied to have a sustainable Indian Sign Language recognition system, but still they are not successful in all senses. Hence, the research is still in the early stage. So the history lies that the ISL uses both hands. So the Indian Sign Language uses both hands. If you go for the American counterpart, you will see that they use only one hand instead of both hands in order to represent the alphabets. Just see in the right side, the pictures are shown that we are using two hands to represent the alphabets. So this Indian Sign Language has been derived from British Sign Language and French Sign Language alphabets. So that is what I said, that it is a derived language. It is not that it is developed in isolation, rather than it is a combination of many sign languages being developed over the world. So our Indian Sign Language is derived by some combinations of British Sign Language and French Sign Language. You see, so Indian Sign Language static gestures for isolated numerals. So in the previous slide, you could be able to see how the alphabets are being shown, and you just see here how the numerals 0 to 9 are being shown in Indian Sign Language. So these are the images, the hand movement through which the hearing impaired people can try to communicate with the others. Now, to go further, so ISLRS, what we are interested to discuss today, it is Indian Sign Language Recognition System, because it is being developed for the Indian context. So it is Indian Sign Language. Indian Sign Language Recognition System involve both hand, face, upper body part movement. So try to understand here, the Indian Sign Language requires the involvement of both hands, face, as well as the upper body part movement. So if we'll go for all the details and taking a image of those and trying to have some image processing methodology applied, and then try to connect it to a output device so that the outside people can understand the communication that is being delivered by a hearing impaired person is achievable. So we'll see those simulation. When I will show you the simulation setup, you can understand. Now you can say that as this Indian Sign Language requires the involvement of both face, hand, and upper body part movement, it needs a great deal of attention to see that the background noise, the many other things, the lighting concepts are all taken care of in a good way. Otherwise, you will see that even though for the same type of gesture, the recognition will not be proper. So we'll see to that what are the things required to see that these images are being taken properly without any noises and without any errors into that. So as because Indian Sign Language involves all these combinations, it is becoming difficult in simulating, in developing tools and devices in comparison to other single-ended sign languages like Americans do. And at the same time, if you compare the static gesture identification with the dynamic ones, it is observed that the static gesture identification is somewhat easier, because the static, you want to understand only the static nature of the identification of any numbers or letters. But dynamic needs all those combinations, hence it is something difficult. In real life scenario, if you go for, you can see that we have to develop an ISLR system that have the ability to identify both the type of gestures, the continuous as well as the dynamic gestures, so that we can interface those particular gestures into the hearing impaired people and to the normal people. That is what it is. The main aim of this particular research is to see that some kind of devices, some kind of tools can be developed. So one of my PhD student is trying to develop a mobile app also. So if you can develop an app also, and through that app, by looking into that, and hearing impaired people can understand what a normal people try to speak. So their speech to text conversion can be done. So some normal people is trying to speak something and hearing impaired people do not able to understand it. Then there is some way of doing a device or some methodology that the speech are converted to text, and that text is displayed in the mobile phone through some kind of app. Then the person can see through the app and understand what the normal people try to communicate. So this is what the people are trying to do. So this is how the Chinese Sign Language and pre-processing techniques. So you can see there. Just this is for your reference to understand how Indian Sign Language and how the Chinese Sign Languages are available. So they may be different. So in various sign language in various country, they have their number of letters separately. So we have our own type of letters and they have their 30 letters. So the sign language, they have 30 letters, and that are being represented here, just for your understanding. Now, how these sign language recognition systems can be thought of? What are the techniques behind how things are being done? So we can say that the sign language recognition systems can be broadly divided into two categories. One is globes or sensor based, another one is vision based. So today people are going through the vision based techniques, whereas earlier the globes and sensor based techniques were more popular. Now, if you go for the globes and sensor-based SLR system, you can see that you can have a globes, you can have a globes, hand globes, and in the hand globes, there are several sensors are being connected, or it was available in that particular globes. Now, when you try to move your hand, and that will sense you what kind of information you try to communicate. So I will show you some pictures also. But here you can understand in real life scenario, this globe or sensor based sign language recognition system is not that much efficient, because the sensors are available. You are wearing a globe, sensors are there. Even though you do not want to speak or do not want to communicate anything to a person, still the movement, wherever you are moving or whatever operation you try to do, that is being recorded in the globes, and that will age because that is connected to a computer through some network. Then your movement is being recorded in a computer. So which the people not always like. So that is why it is not that much efficient, because the people are sometimes they hesitate to use that one. Okay, and because the sensors are also available and sensors are being used in the globes, and because of having the hardware devices very close proximity into your body, then it may also have some side effects. So that are to be looked into when these type of SLR systems are considered for the hearing impaired persons. So it says that this type of globes or sensor-based SLR, you can use some kind of wearables such as hand globes or finger rings, so that through that sensors are being connected and it can be used for communication. And it is being hesitated. The technology or the wearing of globes are not that much accepted by the signers. Signers means sign language users. Even though it is useful, but people are hesitating to use it for their own personal considerations. You see, this is how you can say that hand globes look like. So you see, there is a gloves, and there are many wires connections, and you can see the sensors are in the middle. Okay. Now let us think more about this globes or sensor-based SLR system. How this plays a role, how this technique works. So first of all, whenever we are wearing a gloves, so it will collect the data of gesture performed by different sensors. So there are suppose five fingers are there, and suppose 5 sensors are connected. Then those 5 sensors, whenever any finger is moved or the whole hand is moved, then those sensors will generate the data. And the data is to be analyzed. So once the data is being collected by the movement of the or the hand movement of a particular hearing impaired person, that is to be analyzed, and accordingly the conclusions have to be drawn. And where the conclusion will be drawn with the recognition model. You have a model. What kind of model, how the model will be, that we will see to that in subsequent slides. So we think that we have a recognition model, sign language recognition model. Now the first thing is the input. Input is nothing but the data or the gesture, and how that will be obtained through a hand globe. A person is wearing a hand globe. Movement of the hand globe will generate the data, and the data will be sent to a particular computer, a server, where the data will be stored, and that data will be analyzed through a recognition model. And the recognition model may be a machine learning model. So in case of hand gesture recognition, different types of sensors were used and placed on hand. When the hand performs any gesture, the data is recorded and is then further analyzed. So we can say that the first sensor used was data globes, and now the LEDs has come into existence. This has come into existence looking into the virtual reality and augmented reality that are going on in today's world. Okay, so people might be knowing about virtual reality and the augmented reality. So based upon that only, that in place of data globes that are earlier developed, now LEDs are being fixed. Okay, LED globes are also now available, and it is being developed by the Cornell University, so that the virtual reality through LED lights with Bluetooth and onboard computer about hand movements are possible. So the Cornell University, they do research on this. The article published in 2019, they say that they have developed the hand globes using LED lights with some Bluetooth as a communication, and then there is an onboard computer where the data can be stored. And if you want to take it out, you can take it through chip or through, again, Bluetooth, maybe a communication media to take it to a local computer or somewhere else. So the invention of the first data globe was done in 1977. And people have used the sensors-based approaches. Okay, but as I have said, there are some disadvantages also, because sensor-based approach damages the natural motion of hand because of use of external hardware. You see, you saw the hand globe, the wires are connected, and because of that, the natural motion of hand of a particular person is restricted. Still, research is going on to check whether this is useful. This particular type of applications is useful for physical therapy or sports medicine or not. The recent research going on, people are thinking in terms of, because of this materialistic life, the busy life, people are encountered with many personal problems. So whether this type of things can also be helpful in developing some kind of methodology to have some solution for physical therapy or sports medicine. However, even though it is being used and still researches are going on, the major disadvantages lies in complex gestures. So if there will be complex gestures, hand movements being developed by hearing impaired people, the hand globes or LED based globes cannot perform what is intended for. So looking into those things, the vision based SLR has taken into account. So it has taken the birth, and many researches are going on vision based SLR only. So this approaches, this vision based SLR, sign language recognition, takes image from the camera. So you have a camera as data of gesture. So camera is there, through camera, the gestures will be stored. So the vision based method, again, it concentrates on captured image, and as all of you might be knowing it, the image processing, the main thing behind the image processing is to extract the important features or region of interest. We also need those kind of things in this particular research. So you have an image of gesture and extract the main feature and then try to recognize it. And as you can see in the third line, it is saying that it concentrates on region of interest. Because when a camera is taking a picture or an image of yours, your whole body movement, because we have said that Indian Sign Language takes two hand, face and upper body part into consideration to understand what you try to communicate to the normal people. Now when image takes your face, your two hands and your upper body movement, then it can take some other images also apart from these. So that is how you need to have some region of interest from this real-time video or the photo. And extracts, so that here image extraction, again, you have to do. So extracts only that part which is required. What is that part? The part is two hand movement. Is there any facial expression, or whether there is any body, upper body movement. You have to extract only those part video. Okay, then if it is not, use various kinds of filters so that it can correctly classify. Okay, it can correctly classify. So in order to do that, once this pre-processing is done, then you have to have some skin segmentation algorithm, because the skin is involved, the facial skin is involved, the hand is involved with the skin, the body is also involved with the skin. So a skin segmentation algorithm is going to be developed. Okay, so with some adaptive thresholds, okay, so we have to go for some adaptive threshold mechanism with the skin segmentation algorithms for computer vision applications. So finally, we have to do the extraction. So extracting accurate head feature is a major challenge, because if you will not accurately extract the feature, you will see that similar kind of features will have different meaning. So if you'll see in previous slides, I have shown you many hand movements. You'll see that some hand movements are very close to different meaning. Now, if you will not extract the accurate features with the proper ROI and skin segmentation algorithm, then you will lead to a wrong information. So that is a major challenge in the vision-based approach. So as I was saying, so extraction, when image extraction again we are trying to do, it is also being affected by many factors such as lighting condition and background noise. So you have to have some filter methods to get rid of all these things so that you can get the better extraction. Okay. So the more accurate the detection and extraction, the better recognition results become. Okay. So some type of systems assumes that only visual object is captured, that is in hand. So in order to do that, you can have some rectangular filters. Many people, they might be reading image processing or digital signal processing, they might have read about rectangular filters. Okay, so there are many filters are there, but you can use a boosted rectangular filters, which is a well-known method for detecting hands. In the next slide, I will show you that how that is being used. And the main goal of the vision-based system is to capture image or gesture. So image vision-based system is to capture image or gesture. You see, this is what the vision-based static. This is a static sign language recognition. People say the hearing impaired person shows like this type of sign, then you can understand it is for up, thumbs up. And this is what seen. You just see this is vision-based dynamic sign language recognition system. The hand is being moved. There are so many things are being said, and you just see there is a rectangular box is shown. So that is nothing but the filter. So you capture those part of the hand which has some bodily movement, so they are hand movement. Okay. Now the need for ISLRS, why we need this type of things. So as I have said, many people are the number of people that are going deaf day by day because of the sound pollutions or many other diseases, they are getting deaf because of the age problem, whatever may be. So as the number of deaf people are increasing, so the government of India has tried to come up with some kind of rule that or some kind of methodology to try to see that their human rights of the deaf people is not violated. So unfortunately, till now there has not been any noticeable development is done in the context of development of a indigenous ISLR system. Even though there are a lot of research going on, but not a single ISLR system which is considered to be effective in all kind of situations. So indigenous, sustainable ISLR system for any kind of people. If some people is dark, if some people face is white, if some people hair cutting is something different, or if it is from in India, if it is from South Africa, then various type of people and in general SLR system is not yet being developed. However, people are trying to do continuous research to have a sustainable ISLR system. So as a result, the deaf community is still being isolated from the main community. Okay, now as it is proposed that if this type of system will be developed and easily available as a mobile app, then it is going to be a game changer for the deaf community people, which the government of India is trying to motivate the young researchers to apply for funds through various funding agencies. So the primary aim of hand gesture to build a system which will enable their device to understand specific hand gesture. The gesture recognition was first proposed by Krueger as a new form of interaction between human and computer. So this comes under a human-computer interaction. As a new area of research, you see that human-computer interaction through virtual reality, augmented reality, these gesture recognitions, the sign language recognition, all these things comes under that. So how human-computer interaction. So it has become a very significant research area with the swift advancement in computer hardware and vision system. So, but the key problem in this area is how to make hand gestures understood by computer. So we have developed some methodology to understand the hand gesture, but how it will be understood by the computer. So that is a challenge. So in order to do that, we have to see that the steps that are to be carried out in this particular way. So in order to solve this problem, how the hand gestures to be understood by computer, you have to have some 5 steps. Okay, see. So first of all, you have to acquisition of the data. So collect the data. So how the data will be collected? through some camera or something like that. So you take the gesture images that are captured to train the model. You have a machine learning model or some kind of model you have. You input that data to that. So before applying that data, you have to pre-process it. So that is why raw images are converted to specific format as per the models needed. Then go for this on segmentation. I have said that you should go for the skin segmentation for this particular problem, because your face should also be seen, that wherever there is a face, skin is available, those pixels will be having a value. If there is a short color is coming in between your face and hand, then that is considered to be not to be a skin region. The value of the pixel will be accordingly determined. So accordingly, you can have the matrix, okay, so that it will be sent as an input to the machine learning model. Then you can extract the features. So after recognizing the required elements from the image, feature matrices are prepared. And finally, you perform the classification. And the classification, you can recognize what kind of gesture it is, because previously already some kind of training gestures are already stored in the computer as a training data. Now, ICSST architecture, you can see that this is nothing but the basic architecture. So you can see, first of all, data acquisition, segmentation, feature extraction, classification. Then once it is classified, then what will happen? Then output must be sent either in text or in audio. That is what I have said. So what should be the output? You have classified very brilliantly that what the image is for, what kind of hand movement the classification says, but how do you send it to the outside? How it is helpful, how your machine learning output is helpful to the society, then we can send it, the output in terms of text or audio or something like that. And you see, we'll understand the basic, whatever it is required. You just see, the data acquisition is done through a GIET. It is a camera, it's a more popularly used, or else you can have leap motion camera, LMC, GIET, mobile phones, you have mobile phones having a camera, or any device that is capable of capturing the image or video. Anything can be done, anything can be used to see that a image can be taken. Okay, so whatever gestures are being collected after taking the snapshots using all those devices are forwarded to the SLR systems. So SLR system, already architecture is discussed, it will be sent to the model. Okay, of course, if the gestures, there should be pre-processing, segmentation, everything needs to be done. Okay, so once that is done, then we apply to the SLR system for its recognition and then processing. Now, as we discussed about skin segmentation, you must understand what the skin color model all about is. So the human skin, so when you try to segment the human skin, so you have to have some regions, whether it is skin regions or non-skin regions. And that can be done in terms of colors. Okay, so you have to have some skin color model. Okay, so that skin color model depends upon various skin colors and various lighting conditions. Okay, so now here we see, here we can we have just tried to explain very basic fundamentals I have come up with for this 45 minutes talk. So this we can describe the model for the skin color in chromatic color space rather than that of the RGB model. If you will go for the RGB, then there is a problem in skin color segmentations. So you have to convert this RGB to some other methods. Okay, so we say that the common RGB representation of color images is not suitable for characterizing skin color. Okay, so if you have RGB representation, then it is not suitable. Why it is so? Because the RGB represents not only color but also luminance. So RGB, red, green, blue, you are saying that red, green, blue color is being represented for a color picture, a color image, but they are also associated with luminance. So luminance may vary across a person's face. That is what I said. The indigenous SLR system is not yet developed because of these many difficulties, because a person's face varies with its luminance factor. So luminance may vary across a person's face due to ambient lighting, and hence it is not a reliable measure in separating skin from non-skin region. Okay, so because of this particular, because RGB contains some luminance parameter, and the luminance parameter differs from person's face to face due to because of the lighting condition, okay, and background condition. So it is not a reliable measure. Hence, luminance should be removed from the color representation and to develop a chromatic color space. Okay, so you have to convert this RGB color image to a chromatic image space. So you can have these equations. Through that you can just using some normalization method, you can get the various pure chromatic colors. Now, as I have said that how do you develop a skin color model? The skin color model also used to transform a color image into grayscale image, okay, and such that the gray value at each pixel shows the likelihood of the pixel belonging to the skin. So just now I was saying, if a skin image is there, skin model is there, and skin region is to be found out whether it is belonging to a skin or it is belonging to something else, then we can say that if there is available the binary type of images we can consider, we can say that if there is a skin region, the value is 1. If it is not a skin region or non-skin region, the value should be 0. So in that way, you can say that it is a binary representation of the image. So we can use some appropriate thresholding also, so that with the thresholding, everybody knows the thresholding methods, image thresholding method. There are so many methods, but always it is preferred to have some adaptive thresholding methods, so that it is not biased in developing the classification among the skin regions and non-skin regions. So you have to convert the grayscale image that is obtained previously through some thresholding, so that you can develop a image, binary image, stating which one skin region, which are non-skin regions. So this process of transforming a color image to a skin likelihood image and then to a skin segmented image. So we want to develop skin color model so that it can, we have initially a color image. Now we try to have a skin likelihood image, okay, and then a skin segmented image. Skin segmented image, in the next lecture I will show you what is the skin segmentation method and how does it work. And just before the expert was saying about some segmentation, image segmentation methods. So you can use those things also. So a skin region is defined as a closed region in the image, which can have 0, 1 or more holes inside it. Okay. So its color boundary is represented by pixel with value 1 for binary images. Okay. So all holes in a binary image have pixel value of 0. So if you have, there are many holes are being taken. If the pixel values are 0, then you can say that they are for black. And those are having really skin image, they are something white. Okay. So the values, how many number of holes are there in the skin color model. So you can have the Euler number calculation H is equal to C minus H. And the Euler number can be calculated using your MATLAB inbuilt function is available. So if you go for the MATLAB image processing toolbox, there the Euler number for various calculations, whatever it is given in this particular formula, you put it and you will see that what is the number of holes inside a particular region. Let's see. So you can go for the segmentation. So segmentation, as it is being said, it is the process of segmenting the region of interest. Already it is being said by your previous expert. So you go for the region of interest. Then extracted region of interest can be used to train the model, because we want only those parts which is required for our model. Okay, so we want to understand that only. All other things, background noise, ambient lighting conditions, have to be removed. So once that is done, you can send that particular ROI part to train the model for differentiating gesture from other contents of the image. So that is what I'm saying. So if you will have ROI, then it will only be the gesture, not other than that. So because when you are taking an image, apart from the gesture, many other things are also being available. You remove those things using some suitable image processing methodology. So this can be performed using several methodologies like this, what I have shown here, YCBCR, okay, and HSB or edge detection, canny edge detector, etc., etc. You can use any one of these methods, but popularly it is used that how RGB, as previously I said, IGB is not useful for skin segmentation and hence not suitable for sign language detection. Hence, we have to convert RGB to YCBCR. Similarly, there are many equations available to how to convert RGB to HSB, RGB to any other representations. Okay, but the YCBCR is a very popular method. So you just see YCBCR. Y is the brightness, which is represented as a luma. CB is the blue minus luma. Blue minus luma means Y, so it is B minus Y. CR is the red minus luma, so R minus Y. So like this, you can just convert the RGB to your YCBCR values. So once the YCBCR format is obtained, you can understand how this YCBCR format, color format of an image is all about. So it contains a subset of color coding data. Okay, so that can be done through some chroma subsampling method and is represented popularly in 4:n:n format. 4 is for Y, CB, N, and N. So this left side indicates the luminance, luma indicates luminance, middle digit represents blue channel, and the right digit represents the red channel. Now you'll understand why this blue and red is very much useful in sign language detection. It is observed that whatever image, the skin image, because we are interested in skin image calculation, because hand movement or facial expression or body movement, you'll see that we are interested to see the body parts. Hence, the body parts of the skins are basically represented in terms of blue and red color. So you see in the left side, as my cursor is being shown here, the image acquisition. So you have taken an image here. Input image is taken from a camera. Now you will try to find out a ROI. Then you try to segment it through some methodology like YCBCR or skin mask. Now the output will be looking like this. Then next is your feature extraction. You can go for the extraction of various features. As everybody knows that feature extraction plays a very vital role here. Okay. So good features are necessary. So you can say that there are many feature extraction methods such as Euclidean distance, histogram-oriented gradients. You can see some of articles are published in Elsevier and Springer, how in breast cancer detection using histogram-oriented gradient algorithm or SIFT algorithm or convolutional neural network algorithm. We have applied to image processing and understood how the best classification can be done. Okay, so hence the feature extraction play a very bigger role in any feature analysis or in image processing analysis. Okay, so hence feature extraction mechanism demands to be selected carefully so that the features can be extracted irrespective of orientation, position, and elimination. So without, as I have said, if feature extraction is poor, then similar kind of gesture we will be having a same representation. Then it will be wrong information to the audience or to the common people. You see, this is how the feature is being extracted using some methodology. So input image. Now you can take how the features are being extracted from the image. One is your face, one is the other two are showing your hands to hands. So from that you can say that whether you are looking straight, whether you are looking into any side, whether your hands are up or hands are down, where the hands are caved, what is the inclination of your hands, what is the inclination of your head, and by that what you try to speak based upon the common gesture formats available by each individual country. They have their own representation, as I have shown in previous slides. Then we can come to the classification. So as it is done, we can have the classification. It is not new. Everybody knows that everything you want to do, we have to classify what kind of gesture it is, because the gestures are, the formats are available, and we want to compare that with the that we are trying to give it to the model. We compared it, and then we check whether it is being classified or predicted accurately or not. So you can go for various methodologies. So thing is that here these steps includes a model that is trained Previously using training gesture datasets, we have training gesture datasets. The model takes the input images and identifies the gesture which is next converted to text or speech, as already we have discussed in the previous block diagrams. So these are various classification methods. You can have multi-layer perceptron, neural network, super vector machine, ANN, adaptive motion net kernels, Euclidean distance, genetic algorithms, so and so forth. Thousands of algorithms can be applied. Now, this is the basic implementation model. So, as I have said, let us very quickly come to the conclusion. I don't know, maybe my time is coming to end this presentation. So, let me quickly say this one. So you have input image and ROI locations, then have some segmentations, then try to have some feature extraction. Here the feature is being extracted using convolution and neural networks. Then you can go for the classifications. So whatever feature vector that you are being generated, that are being classified based upon the training features available, and then it can generate the output in terms of some text or voice. So that is what the important. So if you classify a good way, that is okay. That is theoretically, the people they say that you have done good research, that you have classified it, you have classified this, that, with 100% accuracy. But what is the implication, societal implications? So wherever we try to do any kind of research, nowadays people are thinking, even if we apply the research project to DST or CSIR or any agency, they try to understand what is the societal effect, how the society is going to benefit out of this research. Then that is what. So once the classification is done, we say that we have developed a very good algorithm. It is robust. It is performing very good. It is scalable, etc., etc. Whatever, I am not going to discuss about machine learning algorithm comparisons, but you can understand that which algorithm is the best. Accordingly, you will say that the classification accuracy in terms of errors or F measures or kappa or etc., whatever is there, you have measured and say that your model is the best model to classify the gesture in comparison to the available things. Now, what to that? If it is classified perfectly, then what to that? What to me? What to society? What to government? What to the hearing impaired people? If you can come up with an end product, then it can be a very good one. So that is why the result can further be used. So we have done a classification, then the output can further be used as an input to the text-to-speech system. Now you see the IIT Bhubaneswar also doing lots of some crores of rupees in this text-to-speech system. They have got the project. So many organizations or the government is encouraging this type of the research. So you can see that once you do this, then it again takes some methods to do these text-to-speech systems, or it can also be used to feed to a translator system. So that I am trying to speak few lines about these translators. This translator is either a machine translator system or the human translator system. There are many translator systems where you can also have some natural language processing tools can play a role. Okay, so it is a very big area, then you can think of it, but either it can be converted to text to speech, or it can be fed to a translator system which can convert the text into required language. If it is done, then it can be of some use to the end users. So what we are interested for after these particular architectures, we are interested to see that the output can be used as voice commands to control the electronic devices and gadgets. The output can also be used to command the smart home, smart TV, robots, etc. So if that can be done, a hearing impaired people, if or somebody else is trying to use the technology, and the output is achieved through this type of application, then it is good. So this is what we are trying to speak in the previous slides. The output can be applicable to many things. It can be see that IoT based or connected devices, storage devices, display devices, anywhere it can also be used. Now this, you can see the sign language recognition system with some unsupervised feature learning. So here we try to use unsupervised feature learning as sequential information bottleneck clustering algorithms. So you see, so many algorithms, there are so many unsupervised feature learning algorithms available. You can also use some bio-inspired computation algorithms also in order to select the features, such as your ant colony optimization. You can go for elephant search optimization. You can have well optimization. So I'm not speaking about those optimization, but if you go for that, you can have the best features that are available from a particular image, if you understand about that. So you just see here, as my cursor shows, Microsoft Kinect is the picture acquiring device. Then you create an RGB. RGB is not suitable because the image that has been captured by the camera is in RGB format. RGB is not suitable for your skin segmentation, which is useful for your sign language recognition model. Hence, you have to convert it to the skin segmentation model. In the skin segmentation model, you can get face and hands all. Okay, then you can apply some depth threshold. So then you can get the segmented hand. Okay, only you can get segmented hand. Then as you can use either crop or resize the picture. And after that, you can get a image which is reshaped hand. Only you can see the most of the picture lies with the hand only. Then apply this to a deep learning auto encoder. So it is shown here in auto encoder. You can go for the restricted Boltzmann machine. You can go for the long-term, long short-term memory, LSTM, etc., etc. Convolutional neural network. Anything you can go for. Even artificial neural network, support vector machine, you have to think that because support vector machine is a very stable algorithm, or a naive algorithm, or a variant of dynamic naive algorithm, also very stable algorithm. Think of it. So think of what kind of algorithm can be suitable for your particular image, and accordingly try to learn the data by the train the data by this model, and then try to get the prediction. So these are models are given. Everybody knows this is a deep learning model. Autoencoders are there. The activation maps are applied to the softmax classifier with softmax activation function. Softmax activation function is nothing but your exponential logistic function. Okay, logistic, so exponential value is there. So you just put it and get the output. This is what about the model. So there are many literature search. I am not speaking about what the literature search and what the people are speaking. So they have used support vector machines. They got 91.3% of accuracy using multi-class nonlinear SVM. Many people are using many methods. Okay, so just I mixed that. So let me go quickly. So you can have nearest neighbor calculations also. You can think about how do you do that. Nearest neighbor calculation, you have to just see what the researcher says. Researcher is not directly using the RGB images captured by the camera. So RGB images is converted to grayscale images, then employed Otsu thresholding. I have said some adaptive thresholding, then you have to use Otsu thresholding. So this is also very popular thresholding method. We have also used Otsu thresholding method in our image classification in medical images. You can see our paper also for segmentation, and then go for the feature extraction using some Fourier transformation descriptors. And then the database is being created and using k nearest neighbor and cosine distance calculation. So everybody knows about cosine Euclidean Manhattan Minkowski distance. So using this distance calculation, you can find out how closely a gesture is being classified, and it is observed by the authors that it is around 99.23%. So there is eigenvalue algorithm, then conditional random fields, motion-led based adaptive kernel, dynamic time warping, so neural network. So here in the neural network, you can see they used many distance measures, city block distance, Euclidean distance, chessboard distance. Many distance methods have been used, and they have tried to find out which one is the best for your feature extraction. And then the classification accuracy using a deep learning model gives you 91.11%. Here also they have used the RGB model is converted to YCBCR model. Okay, so people have used also here, I was saying, the neural network based particle swarm optimization model, which is known as NNPSO, that is also being approached for the gesture recognition with an accuracy. Just see the accuracy is highest here, 99.96% for identifying 22 number of gestures. So many things are there. Here also the CNN and LSTM model is used. You should see, even though the CNN and LSTM is used, the deep learning model, the accuracy is 72%, near 72%. However, you just see, if it is being used with a neural network and particle swarm optimization, the accuracy is 99.96%. But you have to see that here the 22 gestures are classified, here the 35 gestures are classified. So you cannot just say by looking into the accuracy that the deep learning is is failed to provide you better accuracy or less or good accuracy, whatever it is. So you have to understand what kind of data, because if it is not same data, you cannot compare the algorithms. Now this is how you can calculate the accuracy from the confusion matrix. There is confusion matrix for 11 gesture using random forest. You just see random forest is a supervised learning algorithm, very, very popular algorithm. So ensemble algorithm, you can say this random forest is an ensemble machine learning algorithm. So using machine learning, this random forest algorithm, various activities, that is eyes, hand shape, kissing heart, notes, pencil, so many. So these are the 11 gestures are there. How the random forest algorithm could able to classify the gestures are represented in the confusion matrix. You know what is a confusion matrix, and through this confusion matrix you can find out what is the true positive rate, false positive rate, true negative rate, false negative rate, and then find out what is the accuracy, precision, sensitivity, specificity, etc. So this is a confusion metric for the identifying 5 hand shapes. Okay, so you see these are the facial expressions. Just these are all you can see. These are the activity. I looking into the eyes, hand shape, and kissing at all these things. But here only hand shape. You just see various hand shapes are being given. How these hand shapes are being recognized by your supervisory machine learning algorithm. So you just see how it is being done. Now, finally, we are coming to the conclusion that what the challenges in ISLR systems. So, when we try to develop any systems, we need to see that whether the inputs are correct or not. So, getting a good data is nowadays a very difficult task. So, as of now, there is no such dedicated ISL dataset available that contains a wide variety of ISL signs and samples. And that is why many people, they try to inform their friends. They try to give them pizza. Okay, let us take a chocolate, or let us take a pizza and come up with me, and let us have some photo shots. And they try to involve with their friends, and they take their own image. And from there, they try to develop a machine learning algorithm and try to predict the output. So that is why we have to collect the ISL data sets by various systems that are freely available in the internet. But again, the challenge is in best image segmentation techniques. So even though there are many threshold techniques are there, Otsu-based techniques we have discussed, SIFT is there, many adaptive thresholding method, age-based method, region-based method, clustering method, ANN method, many methods are there, but appropriate technique is to be chosen. So selection of best segmentation technique is also a challenge. Then selection of feature extraction algorithm. Apart from that, feature extraction and optimization I have said. So you can use the feature extraction using wavelet transform. You can use the principal component analysis, independent component analysis, or discrete cosine transform. Optimization technique, you can go for the meta heuristics. Various meta heuristics are multi-objective optimization, such as swarm optimization, elephant optimization, flower optimization, so on and so forth. So many optimization are there. Even nowadays, people are doing the combination, hybridization of the optimization techniques. So whether hybridization is needed or not, that is a different issue, because the main aim of the hybridization method is to see that which to improve the classification accuracy, but to see that which are going to be hybridized, which are going to be mixed, and what are their pros and cons, whether if they are two algorithms, their properties are something different, and you mix it, then the hybridized method will be giving you a disastrous result. So ISR model creation, training, and testing, that is what all the things are required. So we have to develop a model so that it can produce better result. So you have to go for intensive training and then fine tuning of the process so that it can give you highest accuracy. So the measures, the performance measures are in terms of kappa statistics, correlation coefficient, mean square error, absolute error, etc., etc. And there, if you go for the research, people will ask you, why root mean square error? This gives you bias. Why mean absolute error? This gives you bias. Why bias is coming in machine learning algorithm, and whether your data is undersampling or oversampling or overfitting or underfitting, or the segmentation is poor, or many criteria that you have to choose. Otherwise, if you without knowing anything, you will choose any performance measures, then you will see that people will give you comment that they may give you bias in getting 100% accuracy. So simulation environment is, you can use TensorFlow. People are using TensorFlow. They can have some OpenCV functionality. They can use Python, based things. And you see how do you implement this using Python? So what these are the steps. Initially, take audio as an input. In this case, we have taken audio as an input on a personal digital assistant by utilizing the Python PyAudio module. So there is a PyAudio module. Take this one, convert the audio to text using Google Speech API. Then utilizing NLP, that is what I was saying. The NLP also playing a role. So presently utilizing NLP, we break down the text into smaller, simpler, and understandable text. Then use some parsing methods. Some parser. Use some parser. There are so many parsing methods. The computer science or those who are reading about NLP, they can understand. So NLP also, the government of India, government of Odisha also encouraging, so that you can have the Odia text, you can have the Wikipedia in terms of Odia language. You can have a repository of Odia languages. So many things are there. So in that NLP is being used, you can have parsing some techniques, so analyzing the grammar. You can also use some kind of stemmer, what is Levinson stemmer or Arabic stemmer. So these are all NLP type of things. So you can think about that and accordingly get the details about the words, so that good combination about the words, so that the people can understand it. The aim is that. So you have to use a Reliance parser for analyzing the grammatical structure of the sentence and building up the connection between the words, so that it can be understandable. So by utilizing some AI based techniques, you can prepare a model, and we can have data sets of predefined sign language, and ISL generator can input sentences using ISL grammar rules. So you can now, once this is done, now you can apply it to the ISL generator. Now by using artificial intelligence, you can display the converted audio into the sign. So you've taken the audio, now using these methods, the audio is converted now into a sign. Now the converted audio into sign language. So the sign language will be seen by the hearing impaired people and can understand it. So one way in the earlier slides I have said about a hearing impaired people try to communicate with the common man. Now we are discussing here how a common man speaking something, but it is not audible to a hearing impaired, and what are the things to be done so that what you speak is now coming in terms of a sign language. So this is important. This is what we are interested for. So both the things are very much important. Both the communications should be useful. So you can develop an app. You can develop a device, IoT based device. You can develop an app so that what you speak, what the speech can be converted to a text or a sign language, and it can be seen by the hearing impaired person on his mobile phone or something like that. Then the communication is achieved. So these are what I have said. There are translations. I will not speak more about that because human translation is needed when you try to communication between two things done in terms of natural language processing. So you need human or machine translation. So there are various machine translation or human translation methods. You can say that when to use human translation, when to use machine translation, under what circumstances you can see that they are beneficial. We have to understand and accordingly see that these are useful for the needy one. So the conclusion is that after a long struggle by the deaf community, the Central Ministry approved the establishment of ISLRTC, the Indian Sign Language Research and Training Center at New Delhi on 20th September 2015. And this research is more focused towards developing a common ISL dictionary which can be used nationwide. So ISLRTC comes with new science day by day. They try to improve because only 10, 12, 15, 30, 50 gesture is not sufficient. Many people try to do, and it may be in region wise, they may also speak in a different hand movement. So that is why the new signs are coming every year and it is being updated accordingly. So going further, ISLRS can also be backed up by some cognitive technology, making it more powerful and more accurate. So we have discussed that ISLRS is a combination of various emerging technologies: machine learning, image processing, cognitive technology, virtual reality, augmented reality, and then deep learning, and natural language processing. So these are a multifaceted combination to see that such a very challenging task is achieved. So it can be concluded that if a state-of-the-art ISLRS can be developed and freely available to the community, then it is not only going to help the hearing challenged people to convey their message, but also will help normal people to interpret the sign language and to do communication with the signers in an effective way. So which can break the barrier and create a positive impact. And what the people think that they are isolated society, they will not feel like that, and they will be engaged in education, jobs, sports, etc. Some of the references. Thank you very much for patient hearing.
Thank you, sir.
Thank you very much. If you have any questions, you can ask. Otherwise, you can also contact me. The email ID, phone numbers, everything is there in the department.
Thank you, sir. So, do you have any questions, audience?
Okay, time is going fast, so you can share my email ID. If anybody is interested, they can contact.
Hello. Myself, Bharat Kumar Patri. What are the main features of you using machine learning on this concept?
Sir?
Yes.
Sir, we have a question, sir.
Okay, the question is what machine learning is used in ISLR system. As I have said, the machine learning is feature extraction, is a machine learning concept. The machine learning model, you can use some algorithms like neural network algorithm, support vector machine algorithm, you can use it so that you can develop a model and classify that whatever gesture is being shown by a hearing impaired person, the computer can understand it and display it in the display board. So, as I have said, some hearing impaired person is speaking something, okay, or try to show a sign, okay. So that we do not understand. So that will be given to the computer. Computer will compare it with the available gesture and their related meaning. And if it is successful, the corresponding meaning will be displayed or to be communicated to the common people. The common people can understand that, okay, so X or Y is trying to communicate that hi or goodbye or good morning, like that.
Sir?
So, yeah.
Sir, I have one more question. There are many classifiers. Which kind of classifier you are using, sir?
So here I have said that you are using the random forest classifier. I have shown it to you. I have also said you can use the dynamic net bias. You can use sequential information bottleneck clustering algorithms. You can use the neural network algorithm. Okay. So many algorithms. Have you read about these algorithms?
Yes, sir. Thanks a lot, sir.
Okay. Thank you.
Sir, one more question.
Okay.
Hello, sir.
Yes.
Sir, I am Dr. Shishendra Roy, Assistant Professor of Electronics Department here.
Okay.
So actually, I am interested in hardware implementation of this system. Sir, can you suggest that if I use a PGA device, that which algorithm is suitable for this application, sir?
You use any device. There is no issue. Okay, so if you implement in FPGA also, there is no issue. But thing is that the optimization algorithm are fixed. Optimization algorithm, once you have connected a hardware, the hardware is connected to a computer. Now computer will work on the hardware input that is being given to you. So there again the algorithms are same. Classification algorithms are also same. You see any IoT devices that are connected to a computer or to anything for analysis, the algorithms are all same. It is not that we are not discussing about any VLSI related VLSI refinement algorithms. No, we are not discussing about VLSI refinement algorithms, but we are thinking that if you have a VLSI kit, but if you have VLSI kit, now what is the purpose? You have taken an image from a camera. Now what do you want to do with the VLSI kit to do on the image?
Sir. Yes, sir. I want to make a integrated system where, sir, suppose, sir, some deaf person
Yes.
shows some sign, and a person who is wearing a headphone can listen to his what he is saying. I mean, sir,
So he's not saying he's showing. That is what I have shown it in one of my slides. That is what I have shown. That when some deaf person showing a sign, suppose hello sign is showing, it is not understood by a normal person. Then what will happen to do? That sign is to be converted to various image formats, as I have shown in my previous slides. Now, once you convert it, okay, then segment it, then do the feature analysis. Then that particular feature will be compared with the already available features in the computer. You have a computer where already the gestures are available. Okay, now a person who is showing a gesture, that is compared with the gestures available in the computer and compared both with the machine learning algorithm. If it best matches, then a particular gesture is classified, and that particular gesture is meant for what it is being represented there in the computer, and that particular part is understood. Okay, it is saying for goodbye. Then you connect to a speaker where the speaker will speak to the normal person that goodbye. Okay.
Okay, sir.
Did you understand?
Yes, sir. Yes, sir.
So that is why in my discussion I said up to classification it will speak, then it is classified better. But how a normal people will understand that what you have spoken or what you have shown through your hand movement or facial expressions. So if you can connect the computer after classification through some audio or through some text, okay, then the normal people can hear it that okay, that sign is for hello or hi. Or if you can connect through a mobile app, the output will be connected through a mobile app through some API. Okay, and your mobile will display that particular person is saying hello. Then you can understand it.
Yes,
Okay?
sir. Yes, sir.
Okay.
Actually, sir, I always think that which algorithm is, I mean, sir, in terms of complexity, because sir, the hardware, we should think of less complexity, then we can implement it very well in hardware, sir.
No, hardware, complexity, that what complexity you are thinking in terms of image complexity or mathematical complexity or space complexity. Here only 11, 12 gestures are there. There is no space complexity. And when we are trying to use any segmentation or machine learning algorithm, because they are very simple in nature, there is no mathematical complexity. Are you getting my point? So if you have very bigger one, then you can think in terms of space and time complexity or something like that. But here, no such things are there. So still, you can explore if you are trying to implement in VLSI. I don't know, but people are using through some Android board. They can do it. They are doing it, and some IoT-based people are doing it. So try to see related literature and try to understand that what are the methods are there. But till now, whatever researches are done, and even one of my PhD scholar has also published one article in sign language detection. We have never faced about any such type of complexity issues. But still, you can take your friends. That is why I said, because the data sets are very scarce. Good data sets are not available. So many gestures are not available. So you, in your department only, you use your students to have a mockary. You see that how do they try to communicate, try to involve them in some type of gestures, so have a various data set and try to implement. And then you can say that if there are so many huge number of gestures, similar kind of gestures, meaning to a particular text or particular symbol, and whether your algorithm fails to recognize that, then we can understand the complexity that are arising from that.
Thank you, sir. Thank you, sir.
Okay.
Can you just turn on your camera, sir, so that we can take a snapshot, sir?
Yes, sure.
Yes, sir. Thank you, sir.
Thank you. Thank you very much.
Thank you, sir. Thank you for giving your valuable insights in the area of sign language recognition system. We hope that research continues in this area and your address would have paved way to understand the strategies of converging to smart and sustainable technologies. Thank you, sir.
Thank you very much. Shall I leave now?
Yes, sir.
Okay. Thank you everyone for giving me an opportunity to share my research to all of you. Have a nice day. Thank you very much.
The next dignitary to honor us with his presence is Dr. Vasudev Behra. Good afternoon, sir.
Yes. Good evening. Good evening. Good evening.
Good evening, sir. Dr. Vasudev Behra obtained his PhD degree in electronics and electrical engineering with a specialization in microelectromechanical systems from Indian Institute of Technology, Guwahati in 2017. He has completed his Master of Technology, Electronics and Communication Engineering in 2007 and Bachelor of Engineering, Electronics and Instrumentation Engineering in 2002 to 2006 from Gandhi Institute of Engineering and Technology, Gunupur, Odisha. Currently, he is working as an associate professor, grade 2, at the National Institute of Technology, Jamshedpur, since June 2018. During this period, he has executed one research project, guided 5 MTech students, 12 BTech groups, while presently 3 PhD students, 2 MTech students, and 3 BTech project groups are continuing their work under his supervision. He has also served as an associate professor at the Indian Institute of Information Technology, Dharwad, Karnataka from August 2016 to June 2018. He co-founded Article Gore, a publishing house, in 2018. He was he has worked on the mathematical modeling, simulation, fabrication, and testing related to piezoelectric MEMS actuators and surface acoustic wave devices. He has also worked as a senior research fellow in the Department of Electronics and Information Technology, a Government of India sponsored project to develop a center for excellence in nanoelectronics and Thernasto devices. Currently, he has 2 patents, 12 generals, including IEEE, IOP, SAGE, Springer, Elsevier, T&F, 7 book chapters, and 18 national and international conference to his credit. He has research interest in the areas of micro, nano, electromechanical systems, piezoelectric devices, surface acoustic wave devices, and Internet of Things. It is my privilege and honor to invite Dr. Vasudev Behra to throw some light on the smart and sustainable technologies impending in future. Sir, please.
Yes. Thank you for a brief introduction, and I'm very much happy to share my thoughts for this international conference. So basically, I will be presenting some IoT related work for this one. Yes. So I will be discussing about the societal issues related to health. Those things we need to solve it using the some one part of the IoT, that is Internet of Medical Things. So in this IOMT, this has come into picture in a large scale when this COVID-19 hit the world. So during this time, people have seen that there are too much of occupation, or the hospitals are too much of occupied by the patients. It's not only the COVID, other patients are also occupied. But during that time, the patients who used to visit the hospital regularly, think of that some of the elderly persons, well, just like beyond 60-70 years, so they need to visit hospital every month to check up, regular checkup of their health and get some medicines to regular consumption. So in that case, this IOMT has played a bigger role or a huge role. So in this context, I will be going to share some knowledge about this IoT and what are the sensors it will be used for this healthcare thing. Then this IoT in healthcare. Then a specific topic I will be talking about, the thing which is developed by some of my students, and what are the challenges are there for IoT. Then the conclusion part will be there. Okay, so before going to this Internet of Things or Internet of Medical Things, you need to know what is this IoT. The people who are there sitting there, or the students or the faculty members, they all are very, very much acquainted about this machine learning and IoT thing. But to know this thing, to go through this IoT, you need to know the how this internet has evolved, or the internet part, how the revolution came into this position, the today's position. It started with 1969. So in during 1969 to 1995, it is the era of internet of boffins. That means during that time they started developing this internet part. And after that, there was one era came, that is 95 to 2000, that is internet of geeks. That means who are very much experienced, or who are very much interested to share knowledge, to utilize the knowledge, or to add some part to this internet. That is the time, that 95 to 2000. During that time, this is called as the internet of geeks. And then it came the internet masses, that is the period of 2000 to 2007. And during that time, this became little popular. I will not say too much of popular, because in a town, if you will visit just like that, because during 2002 I was there in Gunupur. So if we want to check some internet, then we need to go some of internet cafes were there. So that places like 2 to 3 places were there in the whole town, and you need to go there in a hour basis. There you need to pay around 10 or 20 rupees and get a system. And even that system, that internet is too slow, but you can browse some part and you can come back. So during that time, it hit to the market with the masses, like everyone was using, but not that much of popular. But the time it came 2007 to 11, during this time, this smartphone things, it came to market. And this time it hit with the mobile thing, like through the mobile, people were able to access this internet. Now after that 2012 onwards, it is called as the Internet of Things. This Internet of Things is nothing but it's the definition, how it is added up, those things I will talking about. Now if we will talking about the internet, then what is the impact of internet? The simple impact is, now I am sitting here in my office at Jamshedpur, and I'm talking to all of you who are sitting there at Gunupur. So this is the impact of internet. So it can start with your education, it can start with the business, communications, entertainment, medical or health, those things. Education, simple part. Now what we are doing, this is also part of education. So that means this because of this thing, because of this COVID-19, all of us were very much dependent on the internet to teach. Just like us professors, we need to teach, that we need the internet, and the student to learn this thing, they also require the internet. So that is the part, the education it is playing. So e-learning, starting from e-books, everything, the internet is playing the bigger role. Businesses, now you come to the Amazon, you come to the Flipkart, Myntra, everything, Ola, OLX, everything that those businesses carried out through this internet only. Communication, that is very simple thing, like if we are displaying something here and you are able to see there, then that is one of the part of this communication we are able to make it. Entertainment, this one also very much shown after this period, like 2020 onwards, 2020 onwards, like COVID-19, so many OTT platform came to picture, because so many entertainment, just like picture halls, they were closed down because the government has banned the mass gathering, so you cannot move to any movie or any hall thing. So for that you have subscribed to some G5, Hotstar, so those things you have subscribed. So that is the internet it is delivering to us. Now medical and health, we will be discussing more about this thing. So internet usage and population statistics, if you will see, in 2003 it was around 0.08 per person. The connected devices were there. Okay, that means it is around 6.3 billion people were there, and connected devices were around only 500 million. But as the time progressed, by 2020 the connected devices were 50 billion as compared to the world population of 7.6 billion. So the connected devices per person, it came around 6.58. That means each person is having around 6.58 devices connected to the internet thing. Now, so if you will see how this the statistics, if you will check it, the internet usage and population statistics, if you will see in the green part, this Asia, in Asia, it is used in very much, like 51.8% of the people, they are utilizing this internet. That means 2.6 billion people, out of that around 51.8% internet is using. Okay, so if you will see just like that, in you just compare to North America, then this Latin America, Europe, Middle East, everything, you just, this is a statistic thing, how this internet is. Why we are discussing about this internet? Why we are discussing? Because when we will go to the internet of things, then this part, the internet is the very bigger role in case of the playing this major role of this IoT thing. Now, if we'll talk about this internet and the things is nothing but the devices, the sensors, the actuators, the transducers, those are. But now in this case, if you will see present scenario, around 29% of the desktops are there, whereas 31% phones are connected to the internet. That means the major part is shared by the phones, that means the mobiles. Okay, and after that this desktop and notebooks, they are sharing that part, how much part it is connected to the internet. Now it comes to the internet of things. What is internet of things? This term, the IoT or internet of things, this term is coined by Kevin Aston in 1999. What is internet? Already we know, this is the medium where the data were transmitted or received. Okay, and things are nothing but the sensors or the actuators or transducers. So those are connected with internet, and they used to share the information or data to or via via this internet to a server, or from the server to the actuators. Like that it is working. Do you think this is a new thing? No, it was not a new thing, but the embedded system, earlier the embedded system, it was existing. The embedded system is nothing but your sensor, actuator, and some processing thing at a place, at a single chip. If it is assembled, and it is functioning for a single purpose, then that is embedded system. If the same thing we will work for the real time thing, then that is also is nothing but the internet of things. The same, the real time embedded system is nothing but the internet of things. That means this is the old thing but packaged in a new packet. So that's why it is now famous with the IoT or internet of things. So if you will see, this right side picture, this IoT it is showing, and in this case, it's structures are there, various mobiles are connected, laptops, desktop, these things are connected. Along with that, some things are it is sharing. That means informations are sharing through the internet and received via some of the internet linkages. Okay, now it comes to this one, like whether this is having only this internet of things name. No, it is having various names. It starts with the M2M, that is machine to machine internet of everything, that is coined by Cisco Systems. Wall size web, that is Bruce Senner, they have coined this thing. Skynet, if you have seen the movie Terminator movie, then they have taken a word that is Skynet. The Skynet is nothing but the same, this internet of thing only. In those, if you will see that movie, then all the robots, they are connected with one of the server where they used to get the orders from the bus, and they used to execute those works. Now if we will see, there are so many definitions are there for this IoT. The internet of things is the network of physical objects, devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange the data. If you will see, there are various definitions you will find it that but if you will see all the meaning, it is coming to a single point only, what it is saying, that is what is the IoT it is saying. If you will see in terms of Wikipedia, it is saying that the internet of thing, also called as the internet of objects, refers to a wireless network between objects. Usually the network will be wireless and self-configuring, such as household appliances. So some definitions are existing for various things. Okay, then okay, the people who are going to work it, or if they want something like to work in this IoT or do some project, why they should go for that? Because they need to see there is a scope for that. Suppose you are reading this engineering, then definitely you need to know why you are doing this engineering, either for the job, either to be an employee or to be an employer. To be an employee, that means you have to face some company interviews, just like Microsoft, Amazon, Facebook, or TCS, those things. Otherwise, be an employer. That means you just go for a startup or be an entrepreneur, and you just start taking the students or start taking the employees. So like that, if you are working in this IoT, you need to know the market status of IoT. By 2013, around 9 billion IoT units were there in the world. What is the meaning of that thing? That means the connected devices with the internet and working as per the internet and the sensor actuator feedbacks, that is around 9.1 billion devices were there. And revenue, in terms of your revenue, by 2014 it was around 605 billion US dollars, and expected to grow 28.1 billion IoT devices by 2020. 2013 it is only 9, and if you will see, it's around 3 folds. It is changing with a span of 7 years. Okay, so now if you will see, this is nothing but the how we need to see that. That means the IoT market is vast. if you're working in this area, then definitely you will be going to either you just to start working in this one, start project, or prepare, because maximum companies they are opening a wing for this IoT nowadays. So from the table, if you will see, this is how the devices, consumer electronics to manufacturing, healthcare, retail, transportation, others. These are the devices. How means the revenues, how it is shown by 2012, how it was there, and how it is nothing but moving forward. That means increasing. So if you will see in terms of your this one, like typical view of this IoT. It in terms of your industrial automation, you will be finding the existence of this IoT. Smart home, you will find the existence of IoT. Smart health, smart city, everywhere you will be getting this, the test of this IoT. The simple case I will be talking about this smart refrigerator. Nowadays it has came. Earlier, if you will see, the earlier there was the refrigerator were there, and in there just knob was there, inside there is a knob was there, and where the ice chamber is there, there you need to adjust that one, whether it is the winter season, summer season, or rainy season, or defrost. According that it will be changing. But nowadays the smart this refrigerator, it has came into market, where it adjusts the temperature according to the outside environment. It never bothers about what it is there according to setup, but according to what outside temperature is there, how the atmosphere is there, and what it is doing. Suppose you are this is also connected with the internet nowadays. What you will do is, what you will do with this refrigerator. Now think of that, you are sitting in office. Suppose you are sitting in office in Bangalore, and a refrigerator it is there in the home, and now immediately from office you need to make a tour to something Delhi. Okay, and hopefully the you are going for around 3 to 5 days, and you need to switch up that one. So how you will do that means, you will command there from your office through your mobile, and it can be switch up there. Or if you want to make it some changes, like some temperature change, or suppose if you are there in office and you are coming back and you need to make your food ready means the what are the freezing was there, it need to defreeze or defrost that thing, some part. Okay, so that means by the time you will reach your home, that will be little bit warmer. So those things also can be controlled and done. So this smart health thing I will be discussing in later stage, that which is there in a detailed version. This picture, you just remember, a bigger picture is there for the same version, and we will be discussing for this one. And the same thing, if you will start talking about smart city, industrial automation, the smart health, definitely we are talking smart city. Also I told you that we have carried out one project, that is for the because when I was there at Triplight Dharwad, that time also we are working on this IoT. So there the smart city planning it has came. So for that we started working on the smart lights in the sense the street lights were there. So in general, in a conventional way, street lights used to switch on at evening 6 p.m. or evening 6, and it will continue to glow throughout the night, and by next day morning 6 o'clock it will switch up. Now is it the same for all the weather conditions? Think of that, this is the winter season, this is the summer season. So in terms of a summer season, that means you will be getting a very late evening, till that time you will get bright and environment. So for that, if the light is switched on at 6 o'clock, that means we are wasting some energy, and we are wasting the lifespan of this light which is used there. So according to the atmospheric brightness, we will be adjusting or switching on or switch off that bulb for that. Along with that, what we'll do, and think of that, you have a light in a municipality area, if your home is there, and suppose near to your house there is one street light which is fused. Now if you want to go and complain there in the office, definitely they will take 3 4 5 days to come and repair. It is not that you just complain and they will come and replace it. It will take some time. Now what we will do, simple thing is, as per this IoT, if we will do this Internet of Things application, then the lifespan of the light will be observed. Think of that 1000 hours glowing lifespan is there, and by 950 hours of lifespan, it will give a message to the maintenance office that yes, you have only 50 hours left, so it's better you just go and replace the bulb. So that way it can able to make it can save some part of your time and some part of your difficulty. So these are the typical views are there. So how these connected devices are there, if we will talk about, these are service sectors are there, application groups are there, location devices it is there. Think of that. Just I will start with one service sector, that is a building. A building, it can be of a commercial type or institutional type or an industrial type. So this is your application groups. Think of that, it's a commercial institution. If it's a commercial institutional, then location is nothing but it can be office or education, retail, hospital, healthcare, like that. So if that is the case in industrial way, this is a process, clean room, campus, like that thing. So according to that, what are the devices it is used? It is a HVAC or transport or fire safety systems. These devices will be utilized, or lighting or security. This type of your devices were connected. So according to this thing, the IoT will be come into picture. Think of that, the lighting. So in office hours, a office which runs only from your morning 9 o'clock to evening 5 o'clock, that means what are the lights or the AC or the fans, that will be switched on by 9 o'clock, and by evening 5 o'clock it will be switched off. So this way you need to have the the applications. So for this, what are the enabling technologies are there? RFID, sensor, smart tech, nanotech, these things are there. So what RFID is doing? RFID, it is doing to identify and track the data of things, whereas these sensors, they are used for to collect and process the data to detect the changes in the physical status of things, whereas this smart tech to enhance the power of the network by developing processing capabilities to different part of the network. Now this part it comes it is interesting, that is the nanotech. Why nanotech is very much necessary? Because if you are utilizing the devices at a smaller place, then you need to make the sensors, actuators, or whatever the devices it is used in a smaller version or in a tiny version. So that's why this is the nanotech thing. According to the technical perspective, there are three layers are there. One is your sensing layer, communication layer, the management layer. So the sensing layer is nothing but the sensors or the actuators which are connected there. Okay, that is nothing but called as the things or the nodes. And communication layer is nothing but this internet which used to transmit the data packets either from the sensor part or what are the command to the sensor. The command, how from where this command it used to come, that is from the management layer. Suppose from the sensing layer it is getting the huge amount of your data, and at management layer there are various machine learning algorithms or the data handling algorithms are there. Think of that, there is around millions of data it is available from the sensing layer, and it is transmitted through the communication layer to the management layer. Now from the millions of data, it need to get some conclusion, or it need to conclude some part, and after that conclusion thing, it need to command some work to do for the sensing layer. Now in this case, I will be giving you some interesting example. Okay, if you allow me to share my other screen. So just a minute. Okay, so hopefully this is visible to all of you. Just a minute. Yes. Okay. So now, yes, check it, check it. So now in this case, what it is doing, okay. Now there is one example I'm giving here. Just think of that. I will be working to grow some rice here. Okay. And this is a 10-meter by 10-meter field is there. And in this case, I want to grow some rice. And for rice, for growing some rice, so is it visible to all of you? The slide changes, you are able to see it?
No, sir. Vasudev, sir. Good evening.
Yes, sir. Yes.
No, sir. It is showing till now the technical
Perspective. Okay,
yes.
okay. Then that place only I will be doing. Okay.
Okay, sir. Okay, sir.
Okay. Okay. So hopefully some drawings you are able to visualize now.
Yes, sir. Yes, sir.
Yes,
Now
sir.
it's visible. Yes.
Okay. So now I will be presenting in this mode only, because some examples I will be giving you.
Okay, sir.
Now think of that. This is a 10-meter by 10-meter field is there. This is a 10-meter by 10-meter field is there. And I want to apply this IoT. All these models I want to apply there. How it will be there? So for growing this rice, I need to know the water level. This water level is known from the water table thing. Then the whether it is raining or not. Then it is then I need to know the atmospheric conditions, whether moisture is there or not. So for that, I will be installing some 5 places the sensors. Some sensors I will be installing 5 places at the 4 corners, and a sensor at the center part. Think of that. I want to know the water table. Water table means, you know, this thing from the ground. From the ground, if you will go down, I will say that this is the level 1, this is your level 2, this is the level 3, this is your level 4 thing. Now in this case, every time the water should be there up to this level 2. If it is not there, if it is going down, then I need to make some arrangement so that again it will be poured the water and it should come up to this 2 place. So that's why this 5 sensors I have taken. So that is working as this sensing layer thing. Okay, so they are giving continuously the data to this sensing layer thing. Now here, all of a sudden, because of the rainy days, the water table or the level of the water, it has gone down to 3rd level. Now this data, it is communicated through this communication layer to the management layer. Now here the algorithms are there, or the programs are written, the machine learning algorithms are there, and here what they are doing, they collected the data, and from the average of these sensors, it came out that yes, it has gone 1 level down. Fine. Now what we will do for the next thing, we need to react, we need to arrange something, so that in that way we will be again pouring the water and make it up to 2 level. So in this case, what we will do, we need to start the motor, or start the motor, the pump, start the pump, so that it will pour the water. But is it the only thing we will say the algorithm it will be doing? No, suppose the meanwhile the raining is also done. Okay, the raining is, it is happening. So in that case, it is also additional water, it is coming to the field thing. So that's why it will ask that whether the raining is happening or not, whether the rain is happening or not. If no, then you just start the pump. If yes, then wait and watch up whether how much time, some delay we will be providing, and we will see that whether it is reaching up to this or not. Suppose no, it is not happening, the rain is not happening, then in that case it will start pump. So it will start pump, it will give the command to the sensing layer. Sensing layer means in this case the sensors are there, the actuators are there, the transducers are there. So the motor is coming under the actuator or the transducer thing. So the motor is switched on. Now whether the motor will switch on for the continuous time or it's a indefinite time, no, it is not like that. So it will check that continuously, again it will check that whether the water table it has come to the second or not. Now if it has reached to the second level, then it will command that yes, it has reached to the second level, now you switch off the pump. So this is the technical perspective, if you see how this is working. So what is the meaning of this thing? That means it's a closed loop. The IoT is nothing but a closed loop, where from where it is starting, it should end at that place. That means if you are taking some information, then it should react there, then only it is going to be called as this IoT thing. So this market already I have discussed, and these are the different types of devices enabling IoT, like from the barcode, real-time location tracking, Wi-Fi, mobile computing, GPS tracking, security sensors, passive RFID. So how much percentage it is there? Now, okay. Now, what is this sensors and actuators it is called? Why? Because in the IoT, I already told you, in the Internet of Things, the Internet already the things are nothing but these sensors or the actuators, okay, or the transducer. So you need to know these things also. If you know these things, you know the library files, then only you can able to program it. Either it is the Python or anything you are using the platform to program, you need to know the library files for this thing. So sensors, a device that detects or the measures a signal or stimulus or acquires information from the real world, that is nothing but the sensor. Actuator, a device that generates a signal or stimulus, it is nothing but the actuator part. Now I'm just because I'm going for a healthcare application, I'm just going to put a light on the healthcare application. Yes, the organizer can tell me how much time I have. Ranjita ma'am?
Yes, sir. Yes, sir. I'm there.
Yes, yes. So how much time I have?
Sir, sir, you can proceed, sir. No issue.
No issue, no? Okay. So because I may take some longer time. Okay. So because if you anytime if you want to break it, then you just let me know. So for health related issues, we need to detect the we need to detect. Think of that. We need to detect the glucose in the blood. We need to detect the glucose part in the blood. So this is one of the sensor is there. Okay, a physical sensor I'm showing you. It's a SAW sensor. It is called. In this case, if you're putting the blood, amount, so I think of that some 0.5 ml or that much of amount if you're putting there, from there are some antibodies will be there who are going to attach this antigen, and with that there will be some changes in terms of your quality factor, in terms of your the frequency shift. Because of that, it will be detecting how much glucose content is there in that much amount of your blood. From there it will say you that yes, it is this will say that this will be used for this the medical application. Now this type of sensor can able to transmit the data through the wireless way also. Okay, so that's why one of the sensor I have shown you. And this is also, the wireless saw based gas sensors, because in this case, if any gas it is detecting, that is also they can be able to send the data through the wireless way. And this thing will be used for the industrial applications, or think of that any city we are measuring the, suppose carbon dioxide amount of carbon dioxide. So in that case, this gas sensor will be utilized, and we can able to get the information out of this. Yes, so various applications are there: management, retail, logistic, pharmaceuticals, food, education. This IoT is there. Okay, so this is management house. Suppose if you will go to any of the, the Amazon thing, the warehouse, you will see that in that case, the what are the different packages are there at a warehouse, and how they will be segregated, and according to the orders they will be billed, and the orders, the addresses will be stitched to that one, and it is going to be parcel. Okay, so that place also this IoT is used. Just data management, waste management, production management, urban planning. So just like your pharmaceutical case, intelligent tags for drugs. That means if you will see in pharmaceuticals, that means how many drugs are available. Think of that as specific paracetamol is there. So in that paracetamol thing, how many pieces are there, means what is the stock is there. So from this IoT application, you can have that listing. Or drug usage tracking, means how much this is we are going to discuss about this drug usage tracking. Pharma product website, so emergency, emergency treatment, so these things are applied. For food thing also, control geographical origin, food production management, nutrition calculation. That means once, if you will see in there is video on YouTube. If you will see, like in Dubai, I think one of the hotel is there. There you will not get a, the leaf type of your this food order, or that pamphlet. Okay, there where you will be sitting on the table only, there will be a display. So out of that you will be going to get what food you want, and in that case also it is going to show you. It is not only, suppose you are selecting a chapati. Okay, it is not going to show you only the price. Along with that, how much calories are there, how much nutrition is there, means whether it is good for you or not, everything it will give the detail. So according that you will be selecting, and you will be taking the food. So that is one of the quite impressive application of the IoT. Yes, I was talking about this picture. This is a picture of 1000 watts. If you will see, there is a patient, there is one doctor, and there is another there is one of the, either you can say the supporting staff or the nurse, it is there. Now if you will see this patient, there are various sensors it is attached, and those wires are connected to the collecting devices. Okay, and those information are either it is displayed here, or it is transmitted to the doctor, to the mobile of the doctor, or it is going to the some node station, or it is going to the server thing. From server it can go to the near and dear ones. What they will do, suppose there in this busy schedule life, if you go to any metro city, then think of that there are three persons are there, like a suppose a son is there, a daughter-in-law is there, and a father is there. So in that case, suppose the father is hospitalized, and both the husband wife, they are working in offices, and they have the 9 to 5 job, and this is a for longer time, their father has been in admitted to the hospital. In that case, what they will do, if you are using this IOMT, then regularly they will be getting the updation of the health of their father from the job hours. After that they can visit. Suppose any emergency will be there, then definitely there will be a buzzer or some additional message will be given. No, it's a emergency condition and your patient is not stable, then you just come over here. So like that, in doctor is also used to observe the data which is coming to his or her mobile thing, and if he or she found that it is not a stable condition, immediately he visits the patient and sees that whether it is there or not. So That's why I said this is a pictures of 1,000 watts. You will see how it is going to be. You need to interact, how you will get the information out of this picture. Okay, few examples of IoT in healthcare, that is headsets that measure brain waves, cloths which will with sensing devices, blood pressure monitors, glucose monitors, electrocardiograph monitors, ECG monitors, that is, and pulse oximeters, sensors, those are embedded in medical equipment, dispensing system, surgical robots, and device implants. Any wearable technology devices, that is also coming under this healthcare. What are the benefits for this IOMT or the internet in healthcare thing? That is simultaneous reporting and monitoring. What is that means? The immediately the information, it is collected from the patient, from the picture, if you remember, and that is you are collected and that is distributed to the doctor, to the nurse, to the near and dear ones. Meanwhile, it is also monitored. That means automatically, think of that the oxygen meter is there. Okay, in that case, if the oxygen level it is going down, then means the patient it is unable to extract, then in that case there is a automatic valve will be there which will open, so that the up to the patient the oxygen it is reaching there. That means real-time monitoring via connected devices can save lives in event of medical emergency like heart failure, diabetes, asthma attacks, etc. and etc. So end-to-end connectivity and affordability. See, I told you that if people are working in the offices, then they cannot visit 1,000 times. Okay, that means every time they cannot visit. But if they can get the information continuously on the mobile through the message or like that, then definitely the to and fro, or the hectic schedule, everything will be it is solved. So like that, IoT can automate the patient care workflow with healthcare mobility solutions. In this case, various connectivity will be there, and the price will also go down as the users will go up. Data assortment analysis. In this case, if the more number of these IoT devices will be used in the IoT, then definitely we are getting huge amount of data. Nowadays, you know that if data is there, then you are winning the world. That is the concept, because if you're not getting this data thing, if that means if you have very much of this data of these patients, then you can able to analyze and you can able to produce different type of the pharmaceutical products or the medicines. So that's why vast amount of data that a healthcare device sends in a very short time, owing to the real-time application, is hard to store and manage if access the cloud is unable. But nowadays we are making feasible to store so much of data and process it and analysis it. Tracking and alert. This is one example I will give it. In COVID-19, people they were tested positive, but because of this tracking and alert thing was not there, that's why though the government has told that you should not go and meet with the mass gathering, or you should not go to any mass gathering thing, but still the positive, the COVID-19 positive people used to go there and spread the virus. Okay, so if the tracking and alert system will be there, definitely the management, think of that either from the DM to the medical officers, they can track the patient and they can be alerted if something is happening there. Remote medical assistant. Suppose in villages, if you will go there, you hardly get some primary healthcare systems. Even near to Gunupur, you just visit to some village, I'm forgetting some of the village names, but still if you visit there, then definitely they are all dependent on the Gunupur medical. So in that case, if we are using this IOMT or the Internet of Things healthcare systems, and it's a affordable cost if it is coming, and the regular checkups of a older persons, like suppose a older person who need to check up the sugar level, the BP level, he or she need not to visit the medical regularly, but rather he will be wearing the device, and remotely the data will be transmitted to the doctor, and even the doctor can over the phone or some way it can give the assistance. Okay, research, this research is, if you are collecting the data, then definitely the research is there, and we can able to produce various devices and products. IoT for healthcare can also be used for the research purpose. So what statistics it is saying? Because if we are talking about too much about this IOMT, then what statistics? Every time you use this statistic to get benefited, that means if you are putting your knowledge, or you are investing your knowledge in somewhere where you are not going to get any return back, then that is a best thing. So better if you will read it, this thing, like nearly 9 lakh people in India die yearly due to insufficient access to the healthcare. India, you just check it how much it is there. Okay, death due to poor quality of care, and death due to the non-utilization of healthcare services. This is the blue and green thing it is given, and India, China, Brazil, Russia, these things are there. So if you will come with the IOMT, then maybe this scenario will be changed. Okay. So now so I'm just coming to this one. We have taken we have started working on this thing, and what we are going to address is measurement of necessary body parameters by the patient themselves, communication of these readings regularly with the doctor or caretaker, taking immediate action in case of any emergency, then reminding patient to take their medicines. Okay, so this was the system architecture for our work. Like we have taken some sensors, ECG, heartbeat, and temperature sensor, along with the GPS module and emergency switch. So in this case, we have used the Raspberry Pi board and some output. These are as the input devices, and this is LCD, buzzer, alarm. So those things as the output part. And what are the things it is detected, the collected thing? Either it can display here in terms of LCD, buzzer alarm, those things, or it can be sent to the cloud, through which it can be sent to PC, mobile, tab, to the near and dear ones, doctors. Okay, those things. So this is the flow diagram for this our work, and where we have started with this thing. So these three sensors we have used. Now in this case, basically what happened, before to going for the Raspberry Pi, we have used different boards, because we have used this Arduino Uno board and Node MCU board. This is the Node MCU board and Arduino Uno. In this Arduino Uno, what happens, one of the part is we didn't get the Wi-Fi. We are not getting this Wi-Fi module along with this Arduino Uno. So just in this case, how it is working, this temperature and pulse rate and ECG, these three vital parameters it is measuring, and it is displayed there. So with the whoever the candidate was there, attached that all the three sensors, and yes, all the three sensors, and got that thing. Just like in temperature, we got how much it is, around 24 degrees centigrade, like that thing, and it is transmitted to the server thing in terms of your this ThingSpeak server, and through this you can able to get on the mobile. Or this is just like the heart rate thing, sensor thing, it is checked. And the GPS module, because see that the patient is there walking somewhere, and it got some heart attack or some BP, it has increased to a high level. So in that case, we need to know the exact location of the person, so that immediately we can reach there and take the patient to the medical or some facility thing. So these are the things which is came through the either the message or the mail. Okay, so in this case we have developed some only three things, but in the some other students, they are also working to add some more sensor to be this thing, to make it affordable for all users. So possible improvements are there, just like your body glucose level, blood pressure, those things will be added. And additional if you will take the paid version of this server thing, then we can able to get, see in the ThinkSpeak, if you're using, then you will be getting the message with the delay of 5 minutes. Okay, but if you will take the paid one, then definitely you will be getting on the exact time, on time. So applications are monitoring elderlies and monitoring the patient behavior, stress monitoring, monitoring social activities, preventive healthcare, continuous multi-parameter monitor. So these are the nothing but applications are there. So improving processes are nothing but this finding people and equipment, like tracking hospital equipment. So these things we will add it so that we can enhance the healthcare system in India or in nearby. So where we can use this IOMT to improvise these things. So preventing medication errors and tracking samples, anti-counterfeit measures or the product recalls. So these are the things. Okay, the challenges are definitely the data security and privacy, because if you are transmitting some information related to the health, then people are there to hack it and get benefit for their applications. And integration, if you are adding so many devices to the IoT device, then definitely the processor should be able to handle those. That is the multiple device handling should be there. And data overload and accuracy, cost, definitely the cost will come down once the users will be go up. Then it's nothing but the threats and opportunity. If misunderstood and misconfigured, then IoT poses risk to our data, privacy and safety. If understood and secured, IoT will enhance communications, lifestyle and delivery of the services. So these are some of the references, and thank you. If you have something to ask, then I will be there to answer. Yes, I will, yes.
Thank you for giving your valuable insights in the. Sir, can you switch on your camera?
Yes, I will switch on. Yes.
Yes, sir.
Mhm.
Thank you, sir.
Yes.
Thank you for giving your valuable insights in the area of IoT in healthcare. Sir, I hope your address would have paved way to understand the strategies of converging and to smart and sustainable technologies. Thank you, sir.
Okay. So I will leave now.
Sir,
Yes,
I'm
yes.
having one question.
Yes. Go ahead.
Sir, actually, currently the situation is very worst for monitoring the cardiac arrest problems, and different hospitals also they suffer a lot uh, by detecting the cardiac arrest problem so early. So to avoid all this, nowadays the IoT, or you can say the smart wearable devices, they are being used, and they are very popular also. But
Okay.
still we are finding some problems. So can you suggest us if any way we can improvise the technology so that it can be detected as early as possible? And
Yes.
yes, sir. Yes, sir.
So for that, the same thing it is coming to picture, that is the machine learning thing. What it is showing, we need to get the information or the huge amount of data before to that, and we will see that what are the symptoms. It will go to the final stage of this heart attack or the cardiac arrest thing. Okay, so with that it can give us that, suppose think of that, along with that the supplement some works, just like the blood pressure it is going up, or the something sugar level it is going up, something it is happening with the body, and which
Yes.
is causing something to this cardiac arrest thing. Then definitely that time it will give a signal or symptom that yes, there may be a chance that there will be a cardiac arrest in near future. It cannot say that immediately, like 1 day or 2 day or after 1 hour it will be happening. But if it is going up, some other parameter it is going up, health related parameter, then immediately it will give the signal. So that is one of the thing, and definitely this is a very interesting field to work on, and we can work on and we can make it happen.
Yes, sir. Thank you. Thank you so much.
Okay.
Thank you, sir.
Yeah. So I will leave now.